ಡಾಕ್ಟರ್ ಚಂದ್ರಪ್ಪ ಜಾನ್ರ ಇದ್ದಾರೆ. ಸರ್, ಗುಡ್ ಈವ್ನಿಂಗ್.
ಗುಡ್ ಈವ್ನಿಂಗ್.
ಸೊ ಸ್ಟ್ರೀಮಿಂಗ್ ಆಗ್ತಾ ಇದೆ.
ಓಕೆ.
ಹಾ, ಆಗ್ತಾ ಇದೆ.
ಇಲ್ಲ, ಇನ್ನೇನಿಲ್ಲ ಹರೀಶ್. ಓಕೆ. ಓಕೆ.
ಹರೀಶ್ ಅವ್ರ ಒಂದು ಕರೆಕ್ಷನ್, ಅವರು ಮಧುನಂದನ್ ಅಂತ.
ಮಧುನಂದನ್. ಕಾಮನ್ ಕನ್ಫ್ಯೂಷನ್. ಇಟ್ಸ್ ಓಕೆ.
ಹೆಂಗ್ ಸರ್ ಅದು? ನಾನು ಮಾಡ್ತಾ ಇರ್ತೀನಿ. ಹಾ. ಓಕೆ. ಹಾ. ಓಕೆ. ಸರ್, ಇವಾಗ ನಿಮ್ಮನ್ನ ಪಿನ್ ಮಾಡಿದೆ. ಓಕೆ.
ಬರೀ ಮಧುನಂದನ್ ಅಂತ ಕರೀರಿ, ಸರ್ ಅಂತಲ್ಲ, ಬೇಡ.
ದೊಡ್ಡ ಹೇಳಿ. ಸ್ಟ್ರೀಮಿಂಗ್ ಎಲ್ಲ ಆಯ್ತು, ಎಲ್ಲ ರೆಡಿ ಆಗಿದೆ. ಹುಡುಗರು ಸ್ಟಾರ್ಟ್ ಆಗಿದೆ ಜಾಯ್ನ್ ಆಗಕ್ಕೆ. 15 ಇದಾರೆ ಇವಾಗ. ಓಕೆ. ನಾನೇ ಮಾಡ್ತೀನಿ, ಯಾಕೆಂದ್ರೆ ನಾನು ಒಂದು ಪ್ರತಿಯೊಂದನ್ನು ಒಂದಾದ್ಮೇಲೆ ನಾನು ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ನಾನೇ ವೆಲ್ಕಮ್ ಮಾಡ್ತೀನಿ. ಹೇಳಿದ್ದೀನಿ, ನೋಡೋಣ ಅವ್ರು ಯಾರಾದ್ರು. ನೀವು ಮಾಡಿ. ಓಕೆ ಫೈನ್.
ಒಂದು ಪಾಯಿಂಟ್ ಇತ್ತು ಹರೀಶ್ ಅವರೇ ಅಥವಾ ಇವ್ರ. ಇವಾಗ ನಾನು ಈ ಪ್ರೆಸೆಂಟೇಶನ್ ಮಧ್ಯ 3 ಸತಿ ಕ್ವಿಜ್ ಅಂತ ಒಂದ್ ಸ್ಲೈಡ್ ಇಟ್ಟಿದ್ದೀನಿ. ಕಂಪ್ಲೀಟ್ಲಿ ಪ್ರೆಸೆಂಟೇಶನ್ ಮಾಡ್ತಾ ಇದ್ರೆ ಬೋರ್ ಆಗುತ್ತೆ ಅಂತ. ಕ್ವಿಜ್ ಅಲ್ಲಿ ಮಲ್ಟಿಪಲ್ ಚಾಯ್ಸಸ್ ಕೊಡ್ತೀನಿ, ಗೆಸ್ ಮಾಡ್ಬೇಕು. ಸೊ ಅವಾಗ ಇಲ್ಲಿ ಗೂಗಲ್ ಮೀಟ್ ಅಲ್ಲಿ ಯಾರ್ಯಾರು ಜಾಯ್ನ್ ಆಗಿದಾರೋ ಅವ್ರು ಕರೆಕ್ಟ್ ಆನ್ಸರ್ಸ್ ನ ಇಲ್ಲಿ ಟೈಪ್ ಮಾಡ್ತಾರೋ ಅವ್ರ ಹೆಸರು ಹೇಳ್ಬೋದು, ಫಸ್ಟ್ ಯಾರು ಮಾಡಿದ್ರು ಅದು, ದಟ್ ಈಸ್ ಓಕೆ. ಪ್ರೈಸ್ ತರ ಏನಿಲ್ಲ, ಜಸ್ಟ್ ಮೆನ್ಷನಿಂಗ್ ದೇರ್ ನೇಮ್ಸ್. ಬಟ್ ನನ್ ಪಾಯಿಂಟ್ ಏನಂದ್ರೆ ಯೂಟ್ಯೂಬ್ ಅಲ್ಲಿ ಜಾಯ್ನ್ ಆದವರಿಗೆ ಏನ್ ಆಪ್ಷನ್ ಇದೆ, ಅಥವಾ ಅವ್ರಿಗೇನು ಇಲ್ವಾ?
ಅಲ್ಲ, ಯೂಶುವಲ್ ಕೆಳಗಡೆ ಅವರು ಏನೋ ನಮ್ಮ ಕಮೆಂಟ್ಸ್ ಅಲ್ಲಿ ಕೊಟ್ಟಿರ್ಬೇಕಾದ್ರೆ ಏನೋ ಒಬ್ರು ರೀಡ್ ಮಾಡ್ತಾರೆ.
ಅದೇ, ಯಾಕಂದ್ರೆ ನಾನು ಅದ್ ಅದೇ ಎರಡೂನು ಈವನ್ ಗೂಗಲ್ ಮೀಟರ್ ಆಗ್ಲಿ ಯೂಟ್ಯೂಬ್ ಅಲ್ಲಿ ಆಗ್ಲಿ ನೀವ್ ಯಾರಾದ್ರೂ ಸಂಘ ಹೆಲ್ಪ್ ಮಾಡಿ ಕ್ವೆಶನ್ಸ್ ಬಂದಾಗ ನಾನು ಕರೆಕ್ಟ್ ಆನ್ಸರ್ ಯಾವ್ದು ಅಂತ ಹೇಳ್ತೀನಿ, ಬಟ್ ಯಾರು ಫಸ್ಟ್ ಎಂಟರ್ ಮಾಡಿದ್ರು ಅಥವಾ ಫಸ್ಟ್ 3 ಯಾರು ಎಂಟರ್ ಮಾಡೋ
ಓಕೆ ಸರ್, ನೀವೇನ್ ಮಾಡಿ ಅಂದ್ರೆ ಅಲ್ಲಿ ಇಲ್ಲಿ ಚಾರ್ಟ್ ಅಲ್ಲಿ ಹಾಕಕ್ ಹೇಳಿ, ಅಂಡ್ ಇವನ್ ದೋಸ್ ಹೂ ನಾಟ್ ಜಾಯ್ನ್ ಇನ್ ಚಾರ್ಟ್ ಅವ್ರಿಗೆ ಅಲ್ಲಿ ಕಮೆಂಟ್ಸ್ ಅಲ್ಲಿ ಹಾಕಕ್ ಹೇಳಿ ಯೂಟ್ಯೂಬ್ ಅಲ್ಲಿ. ಸೊ ದಟ್ ನಾನು ಅದೆರಡು ನಾನು ಯೂಟ್ಯೂಬ್ ನೋಡ್ತೀನಿ, ಈ ಚಾರ್ಟ್ ನೋಡ್ತಾ ಇರ್ತೀನಿ.
ಸರಿ ಸರಿ.
ಹಾಯ್ ಎವ್ರಿವನ್.
ಹಾಯ್ ಮಾಲ್ತಿ.
ಅಂಡ್ ನಾನ್ ಪ್ರೆಸೆಂಟೇಶನ್ ಶುರು ಆದ್ಮೇಲೆ ಇಂಗ್ಲಿಷ್ ಸ್ವಿಚ್ ಆಗ್ತೀನಿ, ಓಕೆ ಅಲ್ವಾ?
ಓಕೆ, ಯಾ ಪ್ಲೀಸ್.
ಬೆಳಿಗ್ಗೆ ಒಬ್ರು ನೀವೇ ಫೋನ್ ಮಾಡಿದ ಮಾಲ್ತಿ ಅವರೇ?
ಮಾಲ್ತಿ ಮ್ಯಾಮ್ ನಿಮ್ಗೆ ಕಾಂಟ್ಯಾಕ್ಟ್ ಮಾಡಿದ್ದು.
ಅದೇ ನಿಮಗೆ, ಅದೇ ನೀವ್ ಫಸ್ಟ್ ಇಂಟ್ರೊಡಕ್ಷನ್ ಕೊಡ್ತೀರಾ ಅಥವಾ ಹೇಗೆ ಸ್ಟಾರ್ಟ್?
ಫಸ್ಟ್ I'll start from my side. ಹರೀಶ್ ನಾನು.
ಸೊ ಲಾಸ್ಟ್ ವೀಕ್ ಸಿಕ್ಕಿದ್ರಲ್ಲ ಅವರಲ್ಲ,
ಸೇಮ್ ಕಾರ್ ಪಾರ್ಕಿಂಗ್ ಮಾತಾಡ್ದವಲ್ಲ.
ಕರೆಕ್ಟ್.
Okay, then after that I'll hand out to Malti ma'am. Malti ma'am will from next she'll hand out to you.
Okay, sure.
ಇವರು ಹರೀಶ್ ಅವರು ಅಬೌಟ್ ಟು BGSVSIT ಬಗ್ಗೆ ಹೇಳ್ತಾರೆ, ಒಂದು 2 minutes ಅಷ್ಟೇ. ದೆನ್ ಮಾಲತಿ ಅವರು she will introduce you. Then start your acting in this.
Sure. ಆಯ್ತು.
ಬಗ್ಗೆ ಹೇಳ್ತಾರೆ, ಒಂದು 2 minutes ಅಷ್ಟೇ. ದೆನ್ ಮಾಲತಿ ಅವರು she will introduce you. Then start your acting in this.
Sure. ಆಯ್ತು.
ಬಗ್ಗೆ ಹೇಳ್ತಾರೆ, ಒಂದು 2 minutes ಅಷ್ಟೇ.
ನಮಸ್ಕಾರ ಸರ್, ದೊಡ್ಡೇಗೌಡ್ರು ಸರ್.
ಸರ್ ನಮಸ್ಕಾರ, ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ ಸರ್.
ನಮಸ್ಕಾರ.
ನಮಸ್ತೆ.
ನಮಸ್ಕಾರ ಸರ್.
ಸರ್ ಯಾರು ಅಡ್ಮಿನ್ ಇದ್ರಿ? ಗುರುಜಿ ಅನಿಕೇತ್ ಅನ್ನೋ ಒಂದು ಐಡಿಯಿಂದ ಜಾಯ್ನ್ ಆಗ್ತಾರೆ.
ಓಕೆ ಸರ್.
ಇಲ್ಲ ಅಂದ್ರೆ ಸ್ವಾಮೀಜಿ ಅವ್ರ ಹೆಸರು ಇರುತ್ತೆ, ಶ್ರೀ ನಿರ್ಮಲಾನಂದನಾಥ ಮಹಾಸ್ವಾಮೀಜಿ ಅಂತ. ಇವೆರಡು ಐಡಿನ ಅಬ್ಸರ್ವ್ ಮಾಡ್ತಾ ಇದ್ವಿ.
ಆಯ್ತು.
ಥ್ಯಾಂಕ್ ಯು. ಅದು ಒಂದು 7:30 ಅರೌಂಡ್.
ಓಕೆ.
ನೀವೊಂದ್ಸಲಿ ನನಗೆ ಪಿಂಗ್ ಮಾಡಿ ಸರ್, ನಾನು ಇದು ಮಾಡ್ತೀನಿ, ಪುಷ್ ಮಾಡ್ತೀನಿ.
ಶೂರ್ ಸರ್, ಶೂರ್.
ನಾನು 2 ಸ್ಲಾಟ್ ಇಟ್ಟಿರ್ತೀನಿ, ಫುಲ್ ಆದ್ರೆ.
ಹೌದು. ಯೂಟ್ಯೂಬ್ ಅಲ್ಲಿ ಏನು ಜಾಯಿನ್ ಆಗ್ತಾ ಇದಾರೆ ಸರ್?
ಸರ್ ಅದು ಲೈವ್ ಸ್ಟ್ರೀಮ್ ಇದೆ ದೊಡ್ಡಗೌಡ ಸರ್.
ಅದೇ ಲೈವ್ ಸ್ಟ್ರೀಮ್ ಏನಾದ್ರು ಗೊತ್ತಾಗತ್ತಲ್ಲ ಅಲ್ಲಿ?
ವ್ಯೂವರ್ಸ್ ಗೊತ್ತಾಗುತ್ತೆ ಸರ್.
ವ್ಯೂವರ್ಸ್ ಇದು ಗೊತ್ತಾಗುತ್ತೆ.
ನಾನು 2 ಸ್ಲಾಟ್ ಇಟ್ಟಿರ್ತೀನಿ, ಫುಲ್ ಆದ್ರೆ.
ಹೌದು. ಯೂಟ್ಯೂಬ್ ಅಲ್ಲಿ ಏನು ಜಾಯಿನ್ ಆಗ್ತಾ ಇದಾರೆ ಸರ್?
ಸರ್ ಅದು ಲೈವ್ ಸ್ಟ್ರೀಮ್ ಇದೆ ದೊಡ್ಡಗೌಡ ಸರ್.
ಅದೇ ಲೈವ್ ಸ್ಟ್ರೀಮ್ ಏನಾದ್ರು ಗೊತ್ತಾಗತ್ತಲ್ಲ ಅಲ್ಲಿ?
ವ್ಯೂವರ್ಸ್ ಗೊತ್ತಾಗುತ್ತೆ ಸರ್.
ವ್ಯೂವರ್ಸ್ ಇದು ಗೊತ್ತಾಗುತ್ತೆ.
ನಾನು 2 ಸ್ಲಾಟ್ ಇಟ್ಟಿರ್ತೀನಿ, ಫುಲ್ ಆದ್ರೆ.
ಹೌದು. ಯೂಟ್ಯೂಬ್ ಅಲ್ಲಿ ಏನು ಜಾಯಿನ್ ಆಗ್ತಾ ಇದಾರೆ ಸರ್?
ಸರ್ ಅದು ಲೈವ್ ಸ್ಟ್ರೀಮ್ ಇದೆ.
$342 ಇದಾರೆ ಅಲ್ಲ?
ಅದು ಸಬ್ಸ್ಕ್ರಿಪ್ಷನ್ ಸರ್, ಅದು ಕೆಳಗಡೆ ಇದೆ ದೊಡ್ಡಗೌಡ ಸರ್, ಅದು ಕೆಳಗಡೆ ಇದೆ.
ಓಕೆ. ಇನ್ನು ಜಾಯ್ನ್ ಆಗ್ಬೇಕು.
ಹೌದು ಸರ್.
ಸ್ಟಾರ್ಟ್ ಮಾಡೋದ ಇವಾಗ?
ಒಂದು ಇನ್ನೊಂದು 2-4 ಮಿನಿಟ್ಸ್ ವೇಟ್ ಮಾಡೋಣ.
ಓಕೆ, ಶೂರ್.
So, shall we start? It's already 19:05.
Yes, I know. It's better we start now.
We can start
Yes.
now. Okay. So, around 60 to 70 people joined, including both the
Yes.
streaming as well as here. Okay. So let us start now. Thank you all. Thanks for joining this webinar. Definitely you can enjoy and as well as you can gain a lot of knowledge by end of this webinar. So let us start with first to introduce our organization. Just I will request Harish to introduce to give few words about our organization, the purpose of this webinar and some trainings, whatever it has been conducted so far. Please, Harish, can you please start?
Yes, sir. Okay. I go here, sir.
Yeah, please.
Okay. So are you able to see my screen, sir?
Yes, we can.
Okay. Thank you, sir. Okay. Jai Sri Gurudev. Good evening, all. Namaskara. Welcome everyone for Semiconductor Market Trends and Career Path Web Talk. Thanks for joining this session. This session is organized by BGSVSIT Professional Trust. So, with the blessing of Parama Puja Jagat Guru Padma Bhushana Sri Dr. Bala Gangadhar Natha Swamiji, and with salutation to Parama Puja Jagat Guru Sri Dr. Nirmala Nandanatha Mahaswamiji, I wish to give you all a brief introduction about BGSVSIT Professional Trust. So, member of BGSVSIT Professional Trust consists of members in senior and leadership position in a well-known IT companies. Apart from India, we have a member spread across 20 plus countries and consists of more than 5,000 plus members. The main objective and purpose of this organization is to train, upskill on cutting edge technologies like data science, big data, machine learning, cloud, and artificial intelligence. Our main purpose is to help the student, especially from the rural areas, to get a job in IT companies. We train the students right from building their resume to coach them on how to face interviews, how to transition from campus life to corporate life. We also help them in learn certain soft skills and also communication skills, email etiquette, and others. Day by day, with all your support, more and more IT professionals join their hands, and because of all your support, BGSVSIT Group has become a trust on November 2021. We are able to do all this with the support and guidance of Parama Puja Jagat Guru Sri Dr. Nirmala Nandanatha Mahaswamiji. By recognizing BGSVSIT Trust activities and group members' strength and collective approach, Parama Puja has allocated us an office space for free and also keep guiding us regularly and also getting updates on trust activities. So far, we have placed many students in various IT companies and also helped them in lateral hiring, that is, experienced people who wish to change job, domain, and also on and so forth for their career progression. We have a lot of plans to help our members in many aspects related to their personal professional development. We welcome volunteers who are passionate to help our members, and those interested, please may get in touch with BGSVSIT Professional Trust. If we strengthen this organization further, we will help to reach greater heights and help the society at larger size. So BGSVSIT Trust na ವತಿಯಿಂದ ಪರಮ ಪೂಜ್ಯ ಗುರುಜಿ ಅವರಿಗೆ ಅನಂತ ಧನ್ಯವಾದಗಳು. So thank you. Handing over to Malti ma'am.
Jai Sri Gurudev. Thank you, Harish. Good evening, everybody. As you all know, today we have a workshop on semiconductor. Let me share my screen. I would like to introduce a few lines about Madhunandan. Yeah. Able to see my screen?
No, not yet.
Yeah. Now?
Yes.
Yeah. Yeah, actually, Madhunandan actually has almost 20 years of experience in automotive and semiconductor segments. He's basically from Chikmagalur, studied in Mysore, Chikmagalur, Bangalore, and Germany. His father is also, education background. I think I can say a complete family is like education. One is in IT and the other one is in the medical. His sister, yeah, and he has done electronics and communication engineering from RV College of Engineering, Bangalore, and also he has done masters from Technical University of Applied Sciences, Ingolstadt, Germany, in international automotive engineering with focus on automotive electronics and software. And he has worked on multiple companies. Some of them are General Motors, Opel, BMW, and also he has lived in Germany for about 10 years, and he can speak fluently German. Since he has having a huge experience in semiconductor segments, actually he can able to help us on the market trends and the career paths. Currently, he is working in Renesas Electronics India as an automotive sales account manager. Warm welcome, Madhunandan Maithili Sharan from our BGSVSIT group. And also one thing I would like to highlight, friends, actually we didn't approach Madhunandan. Actually, Madhunandan came back to us as he was already in the WhatsApp group, and he himself showed interest to share this knowledge with us. Thank you all, and huge applause from our end, Madhunandan. Yeah, thank you.
Thank you. Thank you, Manth. Thank you.
Over to you, Madhunandan.
Okay, so I will start sharing my screen. Please let me know when you can see my screen.
Yeah.
So can you see the first slide?
Yeah. Will you maximize a bit? Yeah, Prince.
Yeah, I will go to the presentation mode. Okay. ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. Thank you for the introduction, Malti ma'am, and thank you BGSVSIT Group for giving me this opportunity when I approached with my request to present on a technical topic. So I'm grateful for this opportunity, and also thank you to the entire group. And as you mentioned, with the blessings of Swamiji, we have been helping a lot of students and professionals. So if I can contribute a little bit from my side for that, so I would be happy. So today's topic is about semiconductors and electronics. So I'll talk about the technology, the products, industries that can be served through semiconductors and electronics, and a lot of applications. So I was also told that if I talk about a lot of applications, that gives them a connection to the real world where these are applied, how they are used in our daily lives. So that's what my focus will be. So this is a session that I've planned. The number of slides is close to 40, and I will take maybe a little more than an hour or around an hour and a half. But to keep it interesting, I've included quizzes in between. So overall, there are 3 quizzes after, let's say, 1/3 of the presentation each. And I will show the questions, and then you have to, and with multiple options, and you have to guess the answer and type it in the chat window here, or in the YouTube also. I think there is an option to send the answer that you think is right in the chat window or message window. And regarding question and answers, I think we can have it at the end of the session, because in between, if we break, then it might take longer, and it's already Saturday evening, so I don't want to take much of your time. So I hope I've explained the format of the presentation itself. Yeah. So this is about me. It's okay. Here I've added a photo of my complete family. So I'm married with the one son. He's almost 3 years old, and rest of the things Malti ma'am already introduced about me. I also speak, of course, apart from Kannada, English and Hindi, German, as ma'am said. So I lived in Germany for more than 10 years. So this is the agenda for today's session or webinar. So I'm going to talk about semiconductors and electronics, the economic importance of that. So right away start with the money factor. So why it's important, what are the numbers that make up semiconductors and electronics industries, and some let's say back to school, or not really school but college, where I give 1 or 2 slides of introduction about semiconductors from solid state physics point of view, but it's not going to be boring, 1 or 2 slides, and how they are used in electronics. Then technologies in this industry, which means what are the various software and hardware components that are used in designing, developing, testing, and manufacturing of electronics, where semiconductors are the basic building blocks. And then using these semiconductors, what are the electronic products that become the building blocks of final appliances that we use, devices like computers, smartphones, even in the automotive cars, IoT related stuff. So I'll explain the building blocks of these electronic products. And then the various industries and product segments that are served by semiconductors and electronics. So as I mentioned, in the automotive, which I already mentioned, my background is automotive, electronics, and software. So most of the examples that I mentioned will be from this background because I have hands-on or live experience, so to say. But because I work in a semiconductor industry in the company Renesas Electronics, which makes hardware and software for all these segments, including space. So I would touch upon some of the examples in this. Then these are the industries that can be served, and then the applications itself. So as I mentioned, computers, tablets, smartphones, smart home. In the automotive itself, I give some examples. And then AI. So AI is almost now everywhere. If you're predicting something based on the current behavior, or if you're doing some recognition of face, counting some things, it's already AI. So there is not really, I mean, I'm not going to touch deep upon the technologies of AI, the software or the hardware, the programming stuff that you need to know, but where they are used at application level, that would be my focus. And then a little bit about the career in electronics and semiconductor industry. That means based on my experience in electronics and semiconductor company, and when we hire, what kind of skills we look for. So what are the skills or programming languages or whatever. It's a little different from software and IT. So I'll explain what kind of skills that would be helpful if you learn to get a job in this industry. And what kind of, it's a broad, because here there is hardware, there is software, there is processing, so I mean process manufacturing. So it's a very broad industry, semiconductor and electronics. So there is a wide scope of opportunities and wide scope of skills that you can know. And according to me, it's almost impossible to be an expert in the entire industry, this industry alone. But I'll try to give some examples of skills and job opportunities. Also in my company, so I can share the link of jobs in my company. That's, I think it's already there in the public domain. So you can go there and check yourself out. Check for yourselves. And now I'll start with a small video to show how semiconductors and electronics are playing a role in our daily lives. So before that, I think I have to share audio in my screen. So I will make sure that you are able to hear. Do you know where I can? Anyway, I'll play the video. If you can hear, let me know. Otherwise, I think I have to change. Are you able to hear the audio as well?
Not at
Okay, yeah, I think I have to enable the audio when I share the screen. Does somebody know how to do that? I haven't used this tool a lot. Okay. Maybe I'll stop presenting and then start presenting including the audio. That's how it works in MS Teams, so I'll try that. Also share the tab audio. Okay.
Jai Sri Gurudev Mahaswamiji.
Jai Sri Gurudev, how are you?
ಜೈ ಶ್ರೀ ಗುರುದೇವ್.
ಜೈ ಶ್ರೀ ಗುರುದೇವ್. ಜೈ ಶ್ರೀ ಗುರುದೇವ್. ಪೂಜ್ಯ ಮಹಾಸ್ವಾಮೀಜಿ
ಗೌಡ್ರೆ ಒಂದು
ಜೈ ಶ್ರೀ ಗುರುದೇವ್.
ಜೈ ಶ್ರೀ ಗುರುದೇವ್. ಗೌಡ್ರೆ
ಜೈ ಶ್ರೀ ಗುರುದೇವ್. ಗುರುಜಿ.
Is it okay if I join back on after 15 minutes?
Yes, Guruji.
No worry?
No problem. No problem, Guruji. No problem.
Okay, I will rejoin again back. 15-20
Sure,
minutes.
Guruji.
Okay?
Yes,
wonderful.
Guruji. Sure. Thank you, Guruji.
Does anybody know how to include audio in this? I'm trying to figure out microphone.
Madhu, if you try, there is a 3 dot is there, right? Before that end meeting.
Okay, yeah.
So go there, go to that settings. In the scroll down, go to the settings.
Okay.
And you will find that, see in the left side, audio, video. So try that option. Okay.
Yeah, audio, press on audio. Mute your mic. Okay, I will share the presentation so you can see the video. It just shows the way how semiconductors play a role in our lives, right from the moment we wake up and till the time we sleep. So it's a small video. I'll share it. It's about, again, I found it online, so it's nothing that I've created myself. So instead of wasting time, I'll continue with the presentation. Okay. So
Yes, Madhu.
yeah.
Yes, no problem.
Madhu, we are not able to.
Madhu, we can see your Gmail, not your presentation.
Sorry?
We are able to see the Gmail screen, not the...
Okay. Is it something else? Okay. So now can you see my presentation?
Yeah.
Okay. So I'll just give a brief explanation. So it's just saying when technology stands still or there are disruptions, how our life is affected, and when it's back on, how our life is enabled again. I think recently, last week, most of us in the tech industry experienced this disruption when there was this CrowdStrike malfunction and Windows was down for many hours. So it's just explaining that. I'll continue this.
Madhu, you're not showing your video.
You can see my presentation slide?
Yes, we can see your presentation. Put it into presentation mode, Madhunandan.
Yeah, I had done that. Okay. Now can you see?
No, maybe you're sharing other screen.
I think this video is not getting... See, now it's in presentation mode. Can you see my slide, semiconductors and economy?
No, definitely. That I think you are sharing another screen.
Oh, okay. Sorry, I think because I've not used this. Okay, I will share entire screen. So hopefully now. So now can you see the agenda slide?
Yes.
Presentation mode?
Yes. Yes, now it's better. Yeah.
Okay, so now I will play the video.
Yeah.
Yeah, so it just explained how semiconductors and electronics play such a vital role, right from waking up in the morning through an alarm or whatever kind of mode you use, going through your daily activities, even for high-tech activities like space exploration or satellites. So these kinds of things. That's what I was trying to show. And I think most of us have experienced this last week when there was this disruption of Microsoft Windows operating system through the update of CrowdStrike, which itself is supposed to prevent malware and stuff. But yeah, so both hardware and software play a role, and we have to be aware of how it can affect our lives in both positive and negative way. So hope now you can see the next slide, semiconductors in economy and GDP.
Yes.
Yeah, okay. So again, if I speak a little fast, which I tend to do sometimes, please interrupt me and ask me to slow down. I don't mind that. So the global trade of semiconductors in 2019 itself, so this includes both export and import from various countries, was $1.7 trillion. And semiconductors have contributed approximately $3 trillion in GDP from 1995 to 2015. This is worldwide. And an additional $11 trillion in indirect impact. So there are various industries that are associated with this. As I told, design, manufacturing, testing. I'll speak a little bit of this testing and OSAT that has become a buzzword in the last 1 year or so. And then, next point is about the semiconductor industry reach is expected to reach $1 trillion market value by 2030. And just to give a comparison of this, currently, according to the World Bank figures, the GDP of the world is $105 trillion. And the top 10 countries' GDP alone is almost 70% of that, so $73 trillion. And India is at number 5, so we are close to 4 trillion after USA, which is number 1, 28, China, Germany, and Japan. I think when we overtook a few months ago, UK, it was a big news. So we have overtaken UK and now the number 5 GDP in the world. And the Indian semiconductor market, currently valued at approximately $23 billion, is projected to grow to $80 billion, so almost quadrupling by even before the end of this decade itself. And these are all numbers that I've taken from various sources which I've quoted, government sources, different state governments, national governments, and reliable sources like BCG, or such kind of websites. So the expected CAGR for Indian semiconductor growth is 17%. And coming to our state itself, our state introduced the draft semiconductor policy in 2010 itself. So now it's a completely official and broad policy. It's not a draft anymore. So you can go to the government website and have a look at that. And in 2017, our state launched the Karnataka Electronics System Design and Manufacturing, which is the EDSM policy for the 5 years from 2017 to the next 5 years. And based on this and support from the various initiatives of the government of Karnataka, the expected jump in the overall revenues of the Karnataka's ESDM companies is supposed to be $40 billion by next year. So all these figures are taken from the government website, and when I share the presentation in the note section below, you can see the links and have a more detailed study about these numbers. So as I said, I will go to some topics back to school, as I said. So this will be very basic introduction to what semiconductor is and what are the building blocks. So as you know, all the matter is composed of atoms, and atoms are comprised of protons, electrons, and neutrons. And electrons are the ones that conduct current, that conduct electricity, and then result in materials like conductors, insulators, and in between is the semiconductor level matter. And around this atom, you have various energy levels where the different elements, different components keep moving. And the outermost orbit is called the valence band. So and valence band is the band where these electrons are the furthest from the nucleus, and they have higher energy levels than electrons in lower orbits. And the region beyond this valence band is the conduction band. Why I'm explaining is we cannot use insulator or a conductor in semiconductor. We want to be able to control the current or voltage, and that is only possible when there is something in between conductors and insulators, and that is where semiconductors play a role. This is the diagrammatic depiction of the same. And then the band that separates insulators and conductors is the band gap. That gap is called the band gap. It's between the top of the conduction band and the bottom of the valence band. And when you give enough energy for electrons to move into the conduction band, it becomes conductor. Or in conductor, this band is very low or very narrow. And there is enough conduction band gap in the semiconductors through which you can control the current and voltage. And that is how digital electronics is possible. So you cannot always be having conducting, then it becomes conductors, or insulators like glass. You have to have this enough band gap to have switching between 0 and 1, the digitalization of the world. So, and the other way of, and then coming to semiconductor itself, there are two types of, as I just explained, it's a material that falls between conductor and insulator. So conductor is like copper, gold, iron, and insulator is glass, plastic. These are the materials. And semiconductors have a negative coefficient of temperature. That means the conductivity rises when you apply temperature, right? That's negative coefficient. And semiconductors that are free of doping are called intrinsic semiconductors on the left side. And when you add some dopants like silicon, germanium, these are the dopants that you add, then you get the extrinsic semiconductor. All this is important when you actually manufacture the semiconductor. And then I have some slides where I explain how the semiconductors are manufactured, the various processes, and how you can get intrinsic and extrinsic semiconductor by adding these dopants. And the usual dopants are boron, phosphorus. These are added to silicon, germanium to make intrinsic semiconductors into extrinsic. So all these slides have, right from the beginning, there are questions based on the slides right from the beginning. So just for your information, so if you remember, you can answer the questions easily later. And then apart from the normal semiconductors, there is something called wide bandgap semiconductors. And why this is important is normal semiconductors have a narrow operation voltage range. That means they can be used for consumer electronics and all this phones, computers, tablets and stuff. But then you have the electric vehicles, you have other bigger applications where you need apply much higher voltage range, but still be able to switch. And that is where this wide bandgap of semiconductor materials play a big role. So I think most of you might have heard about these wide bandgap materials. And the main advantage of wide bandgap materials is they can operate at much higher voltage. Otherwise, if you see all the computers, smartphones, smartwatches, they operate at a very low voltage range. You cannot apply hundreds of voltages. Even though you connect to the power 100 voltage or 220 volts, the connector itself will have step down voltage, step down regulator, which will convert it and give the 3.35 volt, 12 volt, whatever is needed. So, but then there are applications that I will show in next slide where you must have a wide range of voltages, frequencies, and temperatures, and still be able to switch, have this digitalization component. So some of the examples are gallium nitride, silicon carbide, boron nitride, aluminum phosphide. These are the WBG range of semiconductors. And they are used in some key applications like some LEDs or lasers, which are based out of the green UV range of spectrum, and in certain radio frequency applications and military radars. So because these have to work at a much higher reliability and temperature range. Also in space itself, there are applications where you need these radiation hardened components, which must be still digital so that you can control it and have lesser power consumption and still have the reliability. So that is where this wide bandgap also play a role. And just to give one example, my company Renesas Electronics has had many components in the Chandrayaan-3 that was launched later part of last year. So our company has products that cater to even the space industries. It's just something about our company. So these are the applications where wide bandgap semiconductor play a role. So infrastructure and IT power supplies, these are huge infrastructure like this power generators or power supplies for IT. So the big server rooms where you have terabytes of data processed, the cloud infrastructure where you have these kinds of data. So those need to be digital, but also able to withstand higher voltage. And consumer and computing adapters, gaming power supplies where you need not just 12 volts or something, but much higher voltages with switching possibilities. Battery chargers and UPS. These are not only used in battery chargers for mobile phones or something, but also EVs. That is what is mentioned here, EV. So whatever basic smaller electric scooters that you see around, those can be managed with normal semiconductors. But as you go to higher range of a powerful Mercedes-Benz or a powerful BMW, which are still EVs, they have voltage of 700 volts, 900 volts. So there you need these kinds of materials. And then 5G mobile adapters, RF material for the power amplifiers, for the base station. So with the increase of 5G or 6G, the base station, that is a telecom base station from Nokia, which is for the intern used by Jio or BSNL, they must be able to handle those kind of power and still be digital and reliable. So that those are the application segments of wide band gap semiconductor materials. This is a rough or overall view of where it can be used, as I said. So you have electric trains as well, right? So those will have huge batteries of big capacity, and then those have to be controlled, and then without any accidents. So the lives of people are the most important thing. So that's where all these applications and these kind of materials play a role. So I'll move on to the next slide. Again, if I'm being a bit fast, you feel free to interrupt me and ask me to slow down. And then where are these semiconductors actually used in electronics? So the most basic element of semiconductors or electronics is the transistor. Transistor is the one that acts as a switch. So this is how it differentiates itself from conductor on the one side of the spectrum and insulator on the other side. So a transistor has 3 terminals typically. So there is the source, there is the drain, and then there is the gate. And source is the source of electrons, and drains the electrons or consumes it. And then by applying the right voltage, you can control the flow of current between source and drain. So that's what transistor does basically. And transistor acts as a switch and as an amplifier as well. So there are transistors where the output voltage is higher than input voltage, because it will input some gain. So that's how it becomes an active component. So that's what I'm going to talk about in the next slide. So electronic components are classified as active and passive. All these are part of electronic device or a circuit that are part of a printed circuit board or PCB as we call, and PCB will have active components like microprocessor or microcontrollers or these kinds of transistors, diodes, as well as passive components like resistors, inductors, which I will show in the next slide. An active component is an electronic component which supplies energy to the circuit, right? So voltage sources, current sources, generators such as alternators or DC generators, various types of transistors. So you have the metal oxide, semiconductor field effect transistors, which operate at a much higher voltage range. So when you want to when you have to do the switching at higher frequency in EVs or other high-end applications, you use MOSFETs, or you have BJTs, so junction transistors, or BJTs or insulated BJTs, IBJTs, which you can use at lower power requirements. And then there are diodes like Zener diodes, photodiodes, Schottky diodes, LEDs, those are the light emitting diodes. These are the typical examples of active components. So I'll move to the passive. What are passive components? So basically, they only receive energy, and they can either dissipate the received energy or absorb it and store it in the electric field or magnetic field and release that later. So passive components. So one of the main examples, capacitor, people might think why it's passive, because you get output, but it does not actually generate itself. It just releases the stored energy with some loss, and we use some amplifiers to make sure the loss is less and almost seem like a gain. So passive elements do not need any form of electrical power to operate. So you just connect a resistor or inductor or a capacitor, and resistor, it dissipates heat, inductor is magnetic field, and capacitor is charge. So that's how they work. And as the name suggests, passive do not provide gain or amplification. They just store it and release it at a later point of time. They cannot amplify or oscillate or generate electrical signals on their own. They need some supply. Examples are as I told. So try to remember these symbols. So again, I'm hinting about the quiz part, about the active components, how they look, what are the names, and about the passive components, how they look, what their names are. So now, I've come to the question part. So these are the 3 questions. Okay, I have not planned it to be shown in one by one. Sorry for that. But answers, at least I have not shown the answers. So I will, so I think, now I think it's a good time, because it was getting a bit theoretical and maybe a bit boring. So I'll switch from the presentation mode so that we can see in the chat window who has sent the answers. And whether they're correct or not. So what elements are added as dopants to make extrinsic semiconductors? You can share your answer in the chat window of the Google Meet tool itself or YouTube. Where is the chat window? Here. Yeah. Okay. Can I make this chat window bigger? Yeah. Okay. Phosphorus, 1B, boron. I mean, please select from the options that are given here. A, calcium, B, phosphorus, C, gold, D, iron. So either mention the option or the answer itself. Yeah, so I think most of you have got it right. You have mentioned the option itself. Okay, boron is also a dopant, but it's not mentioned in one of the options. But anyway, you're not. I'll give that to you. So that's the right answer. Yeah, phosphorus, option B is the right answer. So next question is name any two wide band gap semiconductor materials. So type in your answers here. Yeah, we'll come to the third, fourth, fifth questions later. So now let's stick to the second question. Please mention any two wide band gap semiconductor material. I'm not seeing the YouTube, so hope somebody is monitoring over there. Yeah. Yeah, I mean, okay. Some of the members I know here, they're from the industry, so they might want to hold themselves back. I mean, it's just to make it fun for the others. Of course, you can answer. I know you will mention the right answer. It's okay. Yeah, GNA, I assume you want to say GAN, gallium nitride. Yeah, that's correct. And as I said, even mention the names of people in YouTube. The admin group person who is monitoring YouTube, please monitor over there and mention the names of people who give the right answer. Rajesh Kumar, yeah. But can you name one more material? I had given, yeah, silicon carbide. Yeah, that's the other one. Those are the two main ones which are also in the news. There are many companies that use these materials to make wide band gap applications. But besides these two, I had mentioned few more names, if anybody remembers that, just to see if you are attentive. I know I don't think this is very boring, but because it's quite relevant for the current affairs, politics, geopolitics. So that's why I chose this topic. So anyway. So just to go back in the slide, I will show the other wide band gap materials so that you remember them. GaN and SiC are two of the main ones, but boron nitride, aluminum phosphide, aluminum arsenide, they are also wide band gap materials. Okay, so I mentioned what is an active component and what a passive component is. So in this, and I didn't explain what a diode itself is. Diode is basically a switching device. You give current in one direction, it conducts, and you give current in the other direction, it does not conduct, so it's a switch. So in this way, if you can let me know, is diode an active or a passive electronic component? So the options are A, active, B, passive, C, both, or D, none. Okay. Yeah, most of you have mentioned it as active or passive, but depending on application, it actually works as both. So the answer is it's depending on the application, it's both. So it's an active as well as passive. Again, I have also quoted some references in the presentation, so you can have a look into that to know a bit of theoretical concept why it's both. Especially diode is something where we also ask in interviews, when hiring some of the less experienced guys, and even they don't get it right, so it's okay. But it's both. It can be, depending on application, it will act as an active or a passive component. Yeah, so next one is, I will go back to presentation mode. Question 4, what is the circuit symbol of a transformer? Is it option A, B, C, or D? I will stay here for 10 seconds, have a look at them and mention the correct option. what's the circuit symbol of a transformer? Is it A, is it this, or is it B? This one, is it C, or is it D? I hope you have had enough time to look into that. We'll switch back and let's see who has given the right. Venugoda, Praveen, Vidya Shri, A, D, Mahuna, Mohan Kumar. Okay, A, B, D. All of them are mentioning different options. Okay, I'll mention the answer. It's A, this one. This is a transformer. So whoever has mentioned Vidya Shri, Praveen, R.R. Gowda, Smita Gowda, yeah, it's not D. Aruna Ramalingam. Yeah, so that's that. And yeah, the next question is, which component is represented by this symbol? This means, again, I will hover my pointer over that, this one. Which component is represented by this symbol? Is it A, resistor, B, capacitor, C, transistor, or D, diode? So please mention the option, or you can type the name as well. Okay. Transistor, C, A, C, C. Because we're already close to the 8 o'clock hour mark, so I will be a bit fast. So the right answer is a transistor. So as I mentioned, transistor has a emitter or a source, a collector or a drain, and base or a gate. So you get the output current from the emitter and which is the source, and you get in the part of the circuit which receives the current. The collector will be connected, and you control the flow of current through the base or the gate. So this is a transistor. Okay, so this is the first quiz. There are 2 more quizzes, so please focus more. So just to keep it more interactive and fun, otherwise it will be a bit boring. So I'll switch back to presentation mode and go to the next slide. So I hope you can see the next slide, integrated circuits, if anybody can confirm.
Yes, Madhu, we can.
Yeah, okay. So where transistors are mostly used. So you would have heard the integrated circuits by another name, which I've already mentioned here. So IC or integrated circuit is also known as microchip or a computer chip or simply chip. During COVID, we all were hearing about chip shortage, chip crisis. You can't buy a car because chip ilvante, chip siktila, so whatever like that. So what exactly is chip? It's integrated circuit where a lot of components, including transistors, capacitors, inductors, resistors are manufactured, are combined together and manufactured in a specific way. And then that's what a chip is. And they are etched onto a small piece of semiconductor like silicon or mostly silicon or wide bandgap material. And then you have the chip. And you would have heard, and most of us are from technical backgrounds, so you would have heard something called nanometer technology. You have 45 nanometer, 17 nanometer, or 32 nanometer. So this is basically the gate length. So I just explained you the gate, source, and drain of a transistor. And smaller the number here, the better. That's what I mentioned here. So the smaller means you can integrate more number of transistors in the given area of a silicon chip, silicon die. So that's what is called silicon die or the semiconductor die. So this means you can just have more functionality, more features in a smaller area of the chip. So that's what's meant by the different nanometer technologies. And who are the main companies that manufacture these kind of chips on their own? Intel is one of them, and these are the various nodes, so chip nodes that they have expertise in. I think many of us know Taiwan's semiconductor manufacturing company, which is the biggest manufacturer of semiconductors in the world. Samsung, most of us know. Global Foundries is a US company, SMIC. So these are the various companies that manufacture chips. There are many other companies like the one where I work, Renesas, Texas Instruments. So we are all chip manufacturers, basically. So next few slides are a bit theoretical and you might feel it as boring, but it will give you an idea. This is a very high explanation of how chips are manufactured. It's a very detailed process. It's a very resource intensive, clean process where you must have stable supply of electricity, very clean environment, stable supply of all the relevant raw materials like silicon, and you have to use high-end machines to manufacture these. So basically, semiconductor device manufacturing is a complex process where raw materials like silicon are transferred into finished devices like chips. And the process involves many steps that I've tried to summarize in the next 2 or 3 slides. So wafer fabrication, wafer testing, assembly or packaging, and the final testing. You have the wafer preparation here, and then you have the pattern transfer. So you don't actually include all the resistors or transistors. You make them into patterns and then transfer that into the silicon die. And then you add some dopants that I mentioned earlier to vary the conductivity levels. And then you deposit some other material on top of that to increase, to have some protection. And then you etch that onto the final material where you want to have like a circuit. And then you do the packaging. So this is some theory. So I will just read this. I mean, or not the entire, all the text, but some highlights of from each of the process steps. So wafer preparation is where the most common wafer is silicon wafer. That is chosen as the starting material. And the wafer is clean, polished, and prepared to be a substrate on which rest of the things go. And then the pattern transfer is where a pattern is created on this wafer using a process called photolithography. So there are companies that manufacture these machines, photolithography machines, and some of the big names in this, if you're in the industry, you will know them. There is a company called ASML in the Netherlands, TSMC itself. Applied Materials is an American company, and these are very huge machines, are very expensive machines. So just to give you an idea, ASML sells one machine for 47 million pounds. So by selling 400 of such machines, they had a revenue of close to 19 billion pounds in 2 years ago. So these are very complex machines, and these machines are used to make semiconductors. So that's just to give you how complex and high-end processes these machines employ to manufacture semiconductors. So there is a very long value chain in semiconductor manufacturing, and we'll also explain the term OSAT, which you have heard, where India is entering and some of the companies are investing, what that means and where we are entering. So on the material, on this silicon wafer, you apply this photoresist, and then a mask is placed on the wafer, and then this mask has a pattern that corresponds to the various electronic components. So you don't actually have a transistor or a inductor or capacitor, but the pattern is created, their behavior is simulated, and then they are etched here. And then the doping is done where you change the electrical properties of silicon to make it more conducting or less conducting, or make it a p-type where the majority carriers are holes, or n-type where the majority carriers are electrons. And then by adding these kinds of dopants, you vary the conductivity to have various efficiencies. So you hear about switching 98% efficiency, or whatever input takes, how much output it gives, or how fast it charges a mobile phone or an EV battery. These are the various parameters. So that's how can be controlled by doping. And this process is usually called ion implantation, adding the impurities, and these ions are accelerated to different speeds and implanted onto the surface of the wafer. And then there is the process called deposition. So you deposit the wafer that you have created so far onto a substrate. So the thin film of material are deposited on the wafer to create an electronic component. And there are various processes like chemical vapor deposition, physical vapor deposition, atomic layers. And here you add other materials like metals, oxides, and nitrides. So I mentioned the term MOSFET or FET. So MOSFET means metal oxide semiconductor field effect transistor. So that's how you get different kinds of transistors, and then you achieve that. And then these are etched, whatever you've done so far, they are etched into the surface of a wafer, and you create the desired shape because they have to be compact, right? You have seen a chip, but chip will have billions of transistors inside. So they have to be mounted in the correct shape, and so that they receive the correct current and or the voltage, and then the proper in the right way. And there are various techniques for fetching, wet etching, dry etching, plasma etching, and that's how you actually get that. So this is the first five steps are the manufacturing steps, and then the last step is the packaging step. So when you have this etched wafer, you package that into the final product. The final chip that you see black, that is after the packaging. So inside that are billions of transistors, other semiconductor electronic components that make up this chip. And this chip is packaged in the right way. There are pins coming out. There are various the terminologies itself. You have a BGA packaging or FBGA packaging. There are various terminologies depending on how the pins are coming out, how you can connect them on a printed circuit board, and how you can give the electricity or the current, the power to them. So that is how packaging is decided. So when I go to the next step, what in India we are hearing in the last 1 year, we are establishing OSAT facilities. We are entering at the last step or the most basic step. It's not to say that it's bad, good or bad. It's just explaining where we are entering. So we have a long journey to travel and then become experts like countries like Japan or even Taiwan or US or many countries in Europe. So, but compared to the software industry where, hello? Okay, we started similar. We had call centers, we had business process outsourcing, and then it was mostly human intellect that was needed in the software industry, and you could develop the best software just by being good at some programming language. But semiconductor industry needs huge investment in terms of having the right raw material. If you don't have it, you must depend on the country that has it, have a good relationship with them, and then source that here, and then have the right infrastructure that I mentioned there. So these are the various steps that companies like Japan and US and others started in the 1960s and 70s. So, of course, we have a long way to go there. And so one of the easier ways to enter is this OSAT, outsourced semiconductor assembly and test facilities, where you get the finally designed and manufactured chip. Sorry?
Murali sir, go on.
Hello?
Sorry, Madhu, I think some disturbance. You go ahead.
Okay, yeah. So these are the companies that have invested in OSAT in India. So this is the company I work for, Renesas. So you can remember the logo. So we have tied up with Murugappa Group, which owns CG Smith, CG Stars, CG Power, that is the company, and Star Microelectronics is a Thailand-based company. So we have invested in Gujarat. I mean, most of us have been made to invest there. Micron was the first to come again, and they have the OSAT facility in Gujarat, and HCL has tied up with Foxconn, which most of us know as the maker of iPhone. I think HCL was at least scouting for space or area in Karnataka, and Tata Electronics has tied up with this Taiwanese company called Power Chip Semiconductor Manufacturing Company. Again, it's a Taiwanese company. So Tata Electronics is going to have, I think they're going a little above this value chain. So not just OSAT, but they have a plan to get a little more piece of the pie. So this is what OSAT is. So that's what I want to just explain. So this is all about semiconductors, electronics, what are the basic building blocks, how it is manufactured, and where we are entering, India as a country, where we are entering. So I will share some material where you can have a look about. There is a book called Chip War. It was released in 2022 during the COVID crisis. And this book written by Chris Miller explains how various countries started their journey in the semiconductor. So as I told, when the US was having Cold War with USSR in the 60s, 70s, so and with the support of Japan, they started this. So I will share the materials for the relevant sources for this, and you can have more detailed studies. It's quite interesting why semiconductor is the new framework that even decides policies of governments, be it financial or security policies. So it's quite interesting, this journey, and even this industry. So now switching gears, I will just explain more focus on what are the relevant software and hardware tools and processors that are used in semiconductor manufacturing. This will be also of relevance for students that are here. You can note down some of the tools that I mentioned here, the techniques, like when I say simulation or verification or layout or PCB. These are the techniques where you can have expertise, or you can get trainings, or you might already be having courses in your colleges, and then you can focus on that and slowly learn one technique after another, and then try to become an expert in the chosen area of your interest. So there are various software and hardware that are used in chip design and manufacturing. Please let me know when Guruji comes if you have to stop. I think you will let me know that, I hope, right?
Yeah, please.
Yeah, okay. So there are various computer.
Guruji is there, but he is listening to your lecture actually.
Okay.
Guruji I joined very long back.
Okay. Yeah, Guruji. Yeah, so there are a lot of computer-aided design software tools to create, simulate, and verify IC designs. So you don't directly take a silicon wafer and etch some things and then verify. There are obviously you start digital or simulations on using computers. So there are various kinds of tools that to design analog circuits, digital circuits. Mixed signal means mix of analog and digital, or radio frequency, which you use for telecom. And then there are hardware description language tools, where you design the circuit and then you give some logic, and these are the tools that are used for HDL. And you can decide how, and there are various levels of abstraction again, whether the component you designed is behaving properly, or it has a proper physical structure, or whether signals are getting transmitted between the various components. That is what is meant by physical. So that you can do all in the computer, and then you go to the manufacturing of your own, or there are some contract manufacturers. And then there are various simulation and verification to correctness of your IC design. So before you manufacture, you have to do that. You have to be sure it behaves properly and analyze the ICs at different stages of the design process, like there is a schematic, and there is a layout, and there is post layout. So all these are also job opportunities at my company or the companies which can be of interest to the students or even professionals that are looking to change their domains. And then there are the various layout and synthesis tools to generate the physical representation of the IC based on the logical description done using these HDL tools. And these tools help to optimize the ICs for various parameters, the area, the shape you want, whether it is doing this right amount of milliwatts of power, whether it is operating at the right gigahertz or megahertz speed, and what are the noise levels. So there are various noises along with the signal that you give. So you must be immune to those noises. And then, of course, there are various testing and debugging tools to evaluate the functionality of these fabricated ICs. And these tools help to identify and fix any errors or defects in the ICs, and make sure you have the right performance and the right reliability. Reliability means they must be functional for few thousands of hours, or you must be able to switch on and off. For example, you have this foldable phone, so you must be able to fold them and open it, and then it still should not break for some number of times. So that's a metric for reliability. And then various documentation tools, because once you do all this, you must exchange with your team or with your supplier or your testing company and make sure that he gets the right information to have the right end product. And these are some of the tools that are used for various processes. So CAD software tools are some of the tools manufactured by companies like Cadence, Synopsys, Mentor Graphics, Keysight. All these are the names you might want to remember, and maybe you're already using, because in the courses at colleges I've seen they have licenses for this, and they have labs, digital electronics labs or microprocessor labs, where they use these kinds of tools. And then HDLs were used tools like Verilog, VHDL, System C, and then simulation and verification tools. Some of them are mentioned, the names here, SPICE or Spectre, Model Sim. And then there are PCB layout and design tools. PCB layout is where the design that you have done for a final application. So for example, you want to manufacture a mobile phone charger. So you assemble all the components, and then you design the layout of that. PCB means printed circuit board. And then you manufacture that PCB. So before manufacturing, you can design the PCB layout and make sure all the signals are flowing in the right way, consuming the right amount of current, giving the right output, verify the different signals, and then make sure it's working properly. For this, you have a lot of tools called Altium, which is now a company of Renesas. Altium belongs to us, Renesas. And KiCad, Allegro. There are various tools. I'm just mentioning the most popular tools. Maybe you will say there is one popular tool, but yeah, forgive me if I've not included that. But these are some of the tools that definitely will be useful if you learn them for the students. And then once you design that, as I mentioned, you must make sure the input waveform or the output waveform is proper. And there are tools to make sure to measure these waveforms, like oscilloscope, logic analyzers, multimeters. Even when you have proper memory, so you have this memory chips, you have 4 GB memory or 16 GB memory, and there are some debug tools like JTAG, where you can analyze these waveforms or the signal behavior and make sure your component is working properly. And then documentation tools, where you the documentation also includes the proper representation of the component. So there is a very common famous tool called Visio, where, for For example, for a transistor or a diode or a inductor, there are some specific symbols, and you can use that, and you can show the flow of signal or flow of information. So these are some of the tools in that domain. So next I come to some of the standard communication protocols that are used in automotive application segment. Again, because I am from that background, I mentioned that and then the top. It doesn't mean that's more important than the other. And then there are other industrial application segment communication protocols. This communication protocol is basically you make sure the two components talk to each other properly. That means when I send a 0 or 1 at this particular power, that is voltage and current, the other side receives at the intended value. So that is what communication protocol means. And then you decide the power level, you decide how the signal should be, you decide where the ones go, where the zeros go, and make sure it received correctly at the other end. So one of the most popular automotive protocols, communication protocol, is called CAN, Controller Area Network. It's designed by Bosch. I think most of us know this company. And then Ethernet is if you can say, wired internet. So you use Ethernet very frequently at your house, but it is also used in vehicles and industries to make sure there is fast communication and then wired communication as well. And there is another protocol called FlexRay to achieve higher speeds than CAN. People use FlexRay in the automotive industry, transmission speeds in terms of Gbps or Mbps. And then local interconnect network, LIN, where you use some of the low safety reliant applications like switches or actuators of less safety relevant applications, or sensors where you have the temperature sensor or you have other sensors, automatic wiper. So these kinds of things where it is less safety critical, you use LIN. And then there are a host of wide variety of communication protocols in the industrial segment. The industrial segment is everything apart from automotive. So there is industrial automation, robotics, there is home automation, there is medical electronics, healthcare. All of this use the other kinds of communication protocols. Again, try to remember them. There might be a question later. Modbus is one of them. CCS, and the number 2 and number 3 is what is used for EV charging. So most of you might have a small scooter or even a car, and in your home there could be a station where you connect your car or scooter, and then what is the protocol that is making sure the communication between the source, that is the current giving device, and then the recipient, that is the car or bike, and there is a battery over there. So how they're communicating with each other, making sure there is no battery is not burning, it is receiving enough electricity, and once the charging is complete, it asks it to cut off. Even if you don't switch off externally, the battery is not getting charged. So there is something called CCS, which is used in USA and Europe. There's something called SHADEMO, which is used in Japan and other Asian countries. And there are other protocols like ISO 158118, where you can charge your vehicle outside. There are, I think in India also they're coming up, Indian Oil Corporation and other companies, Shell, they have this EV charging. So you're there, you have to be able to decide how much electricity you consumed, how much you have to pay for that, and authenticate that, all these things are happening properly. So there's some communication protocol for that. Bluetooth and Bluetooth low energy, BT/BLE, I think the headphone that I'm using is Bluetooth. And Bluetooth low energy is where you don't need high fidelity. So something like a tire pressure monitoring system in your vehicles, you must have seen 35 psi is the pressure in the car. So that information is getting communicated from the tires through the CAN network through this BLE module. And again, I mentioned Wi-Fi, wireless fidelity, the Wi-Fi you all know. EtherCAT used predominantly in industrial automation. Digital addressable lighting interface, you have all this LED lighting in the cars, although the government is cracking down on that, but these are done by the OEMs itself. But there are other, you have seen fancy advertisement boards in India itself or other countries like Japan or in the US. So that is the protocol used for this lighting segment. And then there's another protocol called Profinet. So these are the various communication protocols. And now I will talk about the various industries and product segments where semiconductor electronics are used. And then I will follow up this with a lot of application examples. So in automotive, under ADAS, what are the various applications, or infotainment, or in consumer electronics for home theater or wearables, what are the various examples. So I just mention the examples. I will not go into the details. I will share the links. where you can get more details, or where you can also see what kind of electronic components are used, whether you use a microcontroller. Along with microcontroller, what kind of power source you use, do you need something else as a memory device? So all these things, I will share the links. You can have a look into that later. And similarly, after automotive and consumer electronics, there is industrial application segment, where you have various appliances, building and industrial automation, medical and healthcare. Recently in India, government, central government and the state government are spending big on medical and healthcare, because you have this 𝐻𝐢𝐫𝐻 program where the medical data of each of the citizen is stored, and then in the rural area, you might not be having the most expensive healthcare in the primary health centers, but you will still have a glucometer to measure the sugar level, or a pulse oximeter, such things. So there is big spending by the government in these. So what are some of the applications in this segment? Metering, as I just explained, when you connect your car, that is one example, or basic things like water meter in your house, or gas meter in industries, or other flow meters. So that is where it's a very big segment in India, where Renesas is the number one player. Motor drives is where you have this robotic arms. They must be controlled precisely. So there is a motor that is moving this arm. Or in electric vehicles, there is a motor, and that is, there is a battery that is driving the motor, and motor is further connected to the wheels. So that is what drives the car or bike forward or reverse. And robotics is what I just mentioned. Renewable energy and grid, retail, automation, payment. Infrastructure is a bit advanced, where you have this cloud, and you send the data from your local device, which is called the edge, to the cloud, and then that will save it. So that must have a lot of memory to store the data, and it should have huge power supplies and power backup. It should not get erased when such incidents like last week happen. That's what I mentioned, memory. And then you must be able to access that at various points in the world, wherever you're living. So you must have proper wireless infrastructure for that. And digitalization is something that many semiconductor companies are focusing on. Shift left approach is where semiconductor verification, validation, and testing is done as early as possible in the design cycle. So you have this V cycle. I think some of the people in the industry will know. So most of the companies are having this digitalization approach, where the companies don't have to order some component or order an evaluation board and then wait for it to be delivered to their desk, which will take, depending on the lead time and the transportation time, a few days to weeks to months. So instead of that, there are tools that our company and many of our competitors are offering, where the same tool you can see in online, or even there are some virtual labs, cloud lab on the cloud. That's the real lab, and you get access to that through internet, and then you can control this devices. You can see whether that's the right device for your application, and then do some initial analysis, see the physical dimensions, whether it's suitable for you, and then actually buy it instead of other way around. So that's what digitalization is.
Madhunandan, I think now Guruji can just address and bless us now.
Okay, sure. Okay, thank you. Okay, thank you. Jai Sri Gurudev.
Jai Sri Gurudev.
Jai Sri Gurudev.
Jai Sri Gurudev. Jai Sri Gurudev.
It is time to welcome our Parama Pujya, Sri Nirmalanandanatha Mahaswamiji, for this webinar. We are requesting Guruji to deliver a few words to all our IT professionals who have been participated, and students and organizers.
It's okay. Thank you very much. Well, before I do, so can you give me the gist of what's happened till now, though I was listening to? I wish to know what exactly the occasion is for which this is being conducted, and how many delegates have joined.
Yes, Guruji. So to mark the occasion of Your Holiness Diksha Day, BGSVSIT. So usually we used to conduct on 20th itself, but because of there was we wanted to just conduct this webinar on some kind of a niche technology. We were in the process of identifying a speaker to deliver on niche technologies. That is why just we postponed for a week time, and to mark the occasion of Your Holiness Diksha Day, so we've been celebrating this.
What do you mean by Diksha Day?
Diksha Day, when you have Guruji, when Your Holiness has renunciated the worldly life and got
It's
into
okay.
this.
Thank you very much. It is known. Just I am kidding.
Yes.
So, thank you, Madhusudan. Your presentation was wonderful. Just I would like to come to you as a student to learn certain things about semiconductors. You see, till now I did know only thing about the building block of the universe. Today I have been teaching about the building block of this electronics and these appliances, the semiconductor. So during our studies, we used to listen only about the semiconductor, which is laid between the conductors and the insulators. So I didn't know that semiconductor would take the role and the place in deciding the greatness of the countries in geopolitical system. So anyway, at this point of time, I salute to the divine soul of His Holiness Jagadguru, Padma Bhushan Dr. Sri Gangadharan Mahaswamiji, because of which me and you all there as far as this platform is concerned. So I must congratulate these guys in BGSVSIT. Time and again, whenever they have come across such kind of occasion, so they are the first one to make use. Though these people we have been making use of this platform are very well settled in their life. So if they can give this kind of technology and the new knowledge system to the world, the learners are going to be benefited. Thereby they are going to be placed well. So as far as semiconductors and how they can help India would grow, semiconductors are till now we were telling the tiny chips. In one single wafer, billions and billions of chips are there, correct? The way how actually it is going to be produced, all these things you have mentioned in the very beginning, though I joined quite late, I am able to understand the economy growth and all these things. Are these chips and power almost everything we use in our daily lives? Daily lives means from smartphones to household appliances, we have been using this, even to cars and household appliances. So these are like, as I have mentioned, brains of electronic devices. So we have neurons in our brain. So these semiconductors are the neurons of electronic devices. So already you have mentioned how this device works, making them faster, smarter, and more efficient. As our world becomes more digital, the demand for these chips is growing quite high. So once upon a time, we used to use the bigger computers to accommodate the computer. Big room was not at all sufficient. But these days, what's happening? Smaller and better chips. Technology is always improving. It is very well known, and chips are becoming smaller and more powerful. This helps our devices run faster and using the less energy. So these days we have been talking much about 5G technology. The new 5G networks need advanced semiconductors to work. You are all technocrats. I know that it is known to everybody, but we should know if 5G network should be effectively be used, how important the semiconductors are needed. These networks will make internet speed much faster and connections more reliable. So I am sitting in our America Mart. You can see in my backdrop that our Mart address is there. Where we have been using these electronic cars. Modern cars are becoming like computers on wheels. Electronic cars and self-driving cars need lot of advanced chips to operate safely and effectively. So when it comes to when we have been using all these things, global warming and climate change, all these things we cannot forget. So as we advance more and more in technology, the way how we are going to destroy our nature, because nature has been protecting us, but we have been torturing our nature. But when it comes to this one, there is a big push to make chips that are energy efficient also should be there and environmentally friendly and helping to save energy and reduce the waste. And for this, to invite more semiconductor factories and to be established, skilled workforce is needed. Maybe it is because of that this platform has come into existence. Unless and otherwise we have skilled workforce, any amount of establishment of the factory is not at all going to be used. So our country has talented engineers and scientists who can drive innovation in this field, I'm sure of it. But though many engineers and are coming out of our engineering colleges, when it comes to their employability with respect to skill, even today it is a question. As far as the government support is concerned, so somewhere it is being mentioned, in India, in all of India, Karnataka was the first to initiate and to make a policy as far as the semiconductor policy is concerned way back in 2010. So that being the case, forgetting the geographical and state discrimination, if we come forward as a nation, certainly India has the bigger role to play in the geopolitical at the world level. So Indian government, as well as I know, is concerned, it has been offering incentives and support to boost semiconductors, manufacturing and design in our country. As far as the manufacturing is concerned, building factories and infrastructure, India can attract global semiconductor companies to set up their operations here. We know once upon a time how USA and Japan were playing a pivotal role. Later, how it's happened to China. Unless and otherwise we embrace these emerging technologies, it's very difficult to emerge as a global power. These days we have been seeing in our engineering colleges across, even last week also, well before I leave to America, I inaugurated one startup over there, the first circle it seems. So in that, startups are very much needed. It is vibrant in our country now. It's vibrant, startup vibrant scene is being felt and seen, and breakthroughs in semiconductors technology. These these startups can really be helpful when we go ahead with this kind of technology. And when we have been doing that all alone, we can't do that. Global partnerships are also needed. Working with leading semiconductors companies from around the world can help India to learn and grow. Thereby, our children, those who have been coming out from hundreds and hundreds of engineering colleges, are going to be placed very well. As far as the semiconductor industry is concerned, what actually it is going to bring? Though you have mentioned, I have mentioned, economic growth is going to be a pivotal. Today, any country's presence is going to be understood based upon the kind of economy. In the very beginning, just I listened to you. Somewhere we have been reaching the $4 trillion US. $4 trillion US. What we have to understand over here is the country which has the population of 33 crores, means the US, I'm referring the USA. It has the size of economy of more than 28 trillion dollars. When it comes to China with 140 crore population, China is somewhere around 19 or 20. Okay, so our country almost 140, but still we are somewhere around $4 trillion. $4 trillion, correct? Yes. So unless we come forward with this kind of technology, if we don't embrace this manufacturing and this kind of technology, it's very difficult for us to go and reach out those guys. So this is the time for us to embrace these things. Thereby, a strong semiconductor industries can create high-paying jobs and boost the economy. And as far as self-reliance is concerned, developing our own semiconductors capabilities will reduce our dependence on imports. Whatever we get something from somewhere, if we borrow, we have to pay more, whether it's a technology, whether it is a science principle, for everything we have to pay. If we are self-reliable on all these things, obviously a lot of money is going to be served in layman's language to say that. India can become a global center for research and development in semiconductors. When it comes to the research, still we have been lagging behind. Just recently concluded our knowledge engineering in our SJCIT, we have conducted that on the international conference we have conducted. There I was mentioning, even today, as far as the patents are concerned, again, if I take these three countries like America, China and India, the country which has the population of 33 crores, their patent rate is somewhere around 6 lakh patents. Whereas in China, whereas in China, it's about 16 lakh patents. Can you imagine how much in our country? It is somewhere around 61,000. The country which has the population of 150 crores, 148, 150 crores, are producing only the patents rate of only 61,000. China, 16 lakh, and America, 6 lakhs. So this is the kind of thing which would have. So research and development should become more and more even in this semiconductor industry also. Advancing in this field will help India lead in new technologies like artificial intelligence, Internet of Things, and 5G. So, though I am not a technocrat with respect to these semiconductors, so speak what I have understood out of your presentation, and this should be known to our rulers, our politicians, and the general public also, the very importance of the semiconductors, how they are going to play the major role in changing the global, our country, scenery of the country at the global level. As far as the semiconductor is concerned, one should understand if sand, which is the inert material, can bring so much of change into the technology, isn't it? Out of sand, SiO2, silicon dioxide, out of which all this, even quartzite also is going to be a raw material for us to make the semiconductors things out of this. If these inert materials can be helpful in bringing or in making the change and bringing the great future of our country, why should not we make use of our technology? As a sannyasi, when we have been thinking how we can make our people to rise day by day with respect to their level of consciousness, you people have been bringing down the size of the chips to the smallest possible, wherein effectively, if it is used, it is going to make our people quite sublime. One side, Savidya, Yavi the knowledge is that which is going to liberate the person. At the same time, technology, Vijnana, Tantra Jnana, and Jnana, all this should come together, because we can't deny the existence of this world. We can't deny our existence in this world. We have to accept the beauty of this world. At the same time, we have to move forward from the level where we are. So when we have been thinking quite seriously to make our life quite simple, and to reach out to the higher level of consciousness, you people, technocrats, have been working quite efficiently and effectively with full of hard work, how you can bring down the size of all these things with which better, beautiful life is going to be created. By working together, we can build a bright future where India can stand tall in the world of technology without taking much time for having an opportunity. In the name of the Diksha Samarambha. This is the one unique event, making use of which you people have created such a wonderful sublime platform to give a new knowledge for our youngsters, with which they are going to become quite knowledgeable, with which they are going to become, and they are going to have a sublime life in future. So thanking you all for having joined for this program, and in particular with Madhusudan, who has been giving such a wonderful talk, wonderful presentation. Though I wish to conclude, I have to conclude because I have to attend one more program. Thanking one and all those who have participated in this program, I conclude my words. Jai Sri Gurudev. And also I request, I beseech Puja Guruji to bestow best possible benedictions and the blessings upon you all. Jai Sri Gurudev.
Jai Shri Gurudev.
Jai Shri Gurudev.
Jai Shri Gurudev. Dear friends, as many of you are already aware of it, Puja Mahaswamiji is in New Jersey, USA, where he has been there to oversee the construction work of Sri 𝐍𝐢𝐫𝐬 Swami Temple, and is very much busy, occupied for the entire next almost a week time. And in spite of his busy schedule, Puja Mahaswamiji has taken time out of his busy schedule to grace this occasion and also bless participants and organizers who have joined here. And with this, this shows the kind of the love, affection Puja Mahaswamiji has to our BGSVSIT. So he is the source of inspiration for all the members of the BGSVSIT, guiding the youngsters under his leadership to take this training activities, whatever activities we've been doing, to the greater level. With this, on behalf of BGSVSIT, we thank Pujya Mahaswamiji. And
yeah, one more thing, you should have asked all our students to join for this. They could have listened to this one. Had it been shared among the students, at least those who are in final year and penultimate year. Is it?
Yes, Guruji, we have shared it, Guruji. We have shared, and I spoke to all the principals, Guruji.
And see to that, it is not just sharing, and we have to give a responsibilities to all our principals to ensure children join, so that if they start listening, whether they will understand it or not. By now, they are good enough to understand that, but they should understand the very importance of all these topics.
Yes, Guruji. Sure, Guruji. Thank you, Guruji. Thank you. Jai Sri Gurudev. Jai Sri Gurudev.
Jai Sri Gurudev. Thank you, Guruji.
Jai Sri Gurudev. Thank you, Ananda.
Jai Sri Gurudev Swamiji. Jai Sri Gurudev.
So you have got autonomy.
Yes, Swamiji. Yes, Swamiji. Yes, Swamiji. Yes, Swamiji.
It's a wonderful congratulations for having been bestowed with the autonomy.
Pranam, Swamiji.
Jai Sri Gurudev. Always keep it one thing in your mind. Autonomy means the freedom will come with the responsibility.
Yes,
always responsibility is a positive burden.
Yes,
if you know how to manage that burden, certainly you are going to create and you are going to produce good skilled laborers.
Yes,
rather all laborers only. They are all skilled laborers. Thereby, this kind of semiconductor industry is going to be accepted well. Okay, so you have to take responsibility.
Yes,
it should be handled properly. Jai Shri Gurudev.
Yes,
okay, carry on, Madhunandan. Thank you.
Pranam, Swamiji. Pranam,
Swamiji.
Jai Shri. Yes, over to Madhunandan.
Okay. Yeah, thank you. So do you see automotive applications slide?
Yes.
Okay. So now, as I said, I will just explain the various industries and applications that are served by semiconductors and electronics, and which make our lives easier, so to say. So I will start with automotive applications in the field of ADAS. So ADAS means Advanced Driver Assistance System. So these are the systems that will assist the driver to have a more comfortable experience in the car. So most of us, at least if you have heard of it or seen in the vehicles that are being sold in India. So there is something called autonomous emergency braking. So there is a camera or a radar here that measures the distance to the vehicle in front of you, or depending on the application around you. And then if you get too close and not attentive to apply the brakes yourself, it will apply the brake for you. And then the extension of this is adaptive cruise control, where in the highways you can just set the speed, and then the distance will be set automatically based on the speed, and the car will drive itself. And if there is a vehicle in front of you that is braking, your car will slow down. And then when the car in front of you or the vehicle in front of you speeds up, it will follow that. And lane keep assist when you want to change the lanes. Cross traffic alert when you want to again change the lanes, but some other vehicles are coming. So your vehicle will sense that, and it will give you audio warning. And in the worst case, lane keep assist means it will apply some torque to the steering wheel and bring your vehicle back to the lane if you are not attentive to control the vehicle. Traffic jam assist is another one where if it is in slow moving traffic, you can use that again to change the lanes or to some kind of autonomous driving. Driver monitoring system is something where there is a camera inside the car, and then it always monitors the driver even when he's wearing a cooling glass or a mask, and then make sure that it monitors basically all the features on the face, including the eye movement. So if he's drowsy or about to sleep or not attentive using the phone or turning back, and while doing this, if he misses to apply a brake, or if there's a kid crossing the road, then it will alert the driver, and if the car also has AEB feature, it will apply the brake. So this is another option. And then surround view monitoring is very useful in crowded cities like Bangalore or other cities in the world where there is a tight spot and you want to park your car. There are cameras around the car,
or if it is a big commercial vehicle, there are multiple cameras, and the cameras captures the image and they do the stitching of the image and show a bird's eye view of your vehicle, or even a 3D view where you can swipe your vehicle around and see what's around your car and park in the tight spot. Front camera is one of the applications that can be used for multiple of these applications. This is some of the just pictorial depiction. And this is a way, as I mentioned, ADAS, there is another term called AD, autonomous driving. So there are various levels of autonomous driving. Level 1 is basic driver assistance, as I mentioned, lane keep assist or adaptive cruise control. And level 2 is there is partial automation. So DMS, driver monitoring, where if you are inattentive and you're sleepy and there is the need to apply the brake using AEB, that will be taken care automatically or autonomously. This is level 2, partial automation. Level 3 is more conditional automation in highway pilot or automated emergency braking plus steering. So when you want to change the lane, there is another vehicle coming in the lane. So if you are not attentive, if you don't see that, the vehicle itself, based on the electronics and the logic in the functional features in the electronics, brings you back to the lane, or even apply, when you come back to the lane, if there is somebody else braking, apply the brake. This is conditional automation. Then level 4 is high automation. It is city pilot. Or you have seen, I think in the US, there is a company called Waymo, which operates this fleet of robo taxis. That is almost final, level 5 automation. But this is mainly in the city area, this Waymo. So it still comes in the level 4 of AD, autonomous driving. So you can book the taxi, it will come to you, open the door, it will authenticate you based on various parameters, the device you have used for booking, or there could be even face detection. And then you can start the trip, it will drive you and bring you to the destination. And then complete autopilot is the most advanced level, which is technically, I think it's not there at the moment in reality. So there are some vehicles that run on highways, some that run in cities, and some that run in closed industrial environments. So, but in automotive industry, when we talk about ADAS, AD level 5 is the one where it is like a robot. There is some of these vehicles, if you have seen some of the automotive shows in various cities, there is a car where there is no steering wheel even. So you go enter the car, there are seats facing each other, you sit and then you talk to the car and tell where you want to go, it will drive. It will steer on its own, apply the brake, do the things that you ask it to do on its own. So that is there are some prototypes of this, most of the companies have developed, but on real roads, they are still in all the conditions. So Waymo in US, it does it. So it's kind of between level 4 and level 5. And there are some cars that do it on the highway. So that's what these different levels of AD mean. And then there are automotive applications in electric vehicles. So that is quite relevant for us in India and worldwide. So EV, we talk about EV scooters, EV cars, EV trucks and buses as well. So semiconductors and electronics play a major role in these kinds of applications as well. So EV means in EV you will have a motor. So just like motor pump to pump water from ground floor to the top, here also there is a motor, and this motor will usually be an AC motor. DC motors are quite expensive, direct current motors, so it will be, and the power capacity of the DC motors is also relatively less. So that's why mostly we use AC motors, and these AC motors are similar to the engines in the car. And in the car, you fill the petrol or diesel in the tank, and then that is the source of energy. In EVs, it is the battery. And battery stores energy in a direct current format, and then it will convert it into the AC current format and feed it to the motor. So that is what this inverter motor control does. So it's basically engine, then petrol or diesel is the battery, and then and the current that goes in is the petrol or diesel. The battery is the storage tank, so to say, the fuel tank. And there are electronics and semiconductors that play a major role in this, and our company also has a lot of applications for this. Battery management systems itself is where you make sure the energy that you provide to the battery is stored properly and it does not catch fire. I think in the last 1 or 2 years, you've heard examples of Ola scooters catching fire or some other scooters. That is because maybe they did not take care of all the features, all the protection or safety measures. When you're using for an application like automotive, where the engine can reach very high temperatures, or you will drive in various driving conditions, you must follow some safety mechanisms. Or if there is some fault, that is happening, you should go to a fail-safe or fault-tolerant mode or limp home mode, as we call it in industrial terms. So you make sure that when there is a fault, you take some action to make sure the impact of the fault is reduced. So that is why this Ola, maybe because they were not using the right automotive quality batteries itself, and there were no systems like battery management systems which measure the temperature or the humidity or the current range, and when it crosses something, you can cut off the supply to that. So because they were not using that, they learned the hard way, or the government could have been careful and said only such devices are allowed. So if we are learning in a much slower pace, and based on the value of we give it to the life, we formulate the policies. So anyway, that's a different topic, but BMSs do this job. Then position sensing is where, depending on the motor, how fast it rotates, you must know exactly which position it is in, so that you can give that much amount of current, so that you get enough torque and speed and efficiency in your vehicle. Just like in petrol and cars, you have the engine management system and engine control unit. You open the valve in the engine, in the internal combustion engine, and then you inject the fuel, and then you ignite the fuel. The 4-stroke engine is what I'm talking about. And then there's the exhaust cycle. So similarly, you have position sensing, where you know exactly what position the motor is in, and based on that, you give enough current or voltage. This is the EV range of applications. And then this is more relatable or more fun kind of application, the infotainment, which is information and entertainment. So you have the digital clusters. You have seen most of the new vehicles have this. There is no real hardware needle or the hardware dials. It's all digital clusters. You have a digital dial, and there's a needle that is moving digitally. So it will show the speed, RPM, some of the telltales like indicators, fuel level, if there are any temperature indications of battery or engine. So all these are shown in this digital cluster. And this digital cluster nowadays is almost like a smartphone. As Guruji was mentioning, cars are almost seen like computers on wheels, or mobile phones on wheels even. So they must have all the connectivity features, like it should be able to connect to the internet, it should be able to have navigation features, and listen to the music, answer a phone call. All these are possible using this digital cluster. This is mostly when you have one screen. Typically in a two-wheeler. And then there is the advanced next variant of this, where you have infotainment, which is the speedometer, odometer, and then the in-vehicle infotainment, which is a central console of your car, where you can connect your mobile. If it's an Android phone, you can see Android features. If it's an Apple phone, you can see the Apple CarPlay or Android Auto. And then you can access Google Maps or Spotify, or make calls, answer calls, talk to the mobile, and or if your vehicle has eSIM, electronic SIM, then it will have internet connectivity on its own. If that feature is not there, in some entry-level cars, they provide this kind of digital cockpit where you can connect your phone, and smartphones, 99% will have internet connectivity, right? So they will use that, and then you can speak to it, ask it to drive you, at least enter the destination of in the Google Maps, or play a song. So this is called the cockpit. So the clusters and infotainment together is called a cockpit in a car. And then there are in-cabin wireless power. So many of the cars in advanced cars, high-end cars, have this wireless phone charging. Of course, you can connect the typical USB or Type-C USB, and then into the car. There's a power outlet, and then into the phone. That's the wired method. Or there is this wireless power, where you just keep the phone, and then there are some technology. There is a coil that is getting power from the battery. For all this, the battery is the main source. You should remember that. So that is why you have to manage the power, you have to manage the current flow, make sure that the devices are not damaged, and then you charge the power. So typically these wireless chargers, they charge slowly, because that's not their main job, but at least to give you some aid if your battery is dying, if your device is shutting down, you can use this. And the next level is a bit more on the mechanical side, which also uses electronics. So this is the vehicle control systems. EPS is the electric power steering. So in earlier days, you had to turn the steering wheel 3-4 times to even move the vehicle by 45 degrees, so to say. I'm exaggerating, but nowadays you have electric power steering, where there is a motor controlling the movement of the steering wheel itself and measuring the exact accurate position of the steering wheel. And then based on the input you give to the wheel, it will move by that much angle. So this is possible using electronics and semiconductors, where accurate input is detected and accurate output is in the form of steering the vehicle. By that much is possible. TPMS is a tire pressure monitoring system. As I mentioned, it uses the communication protocol of Bluetooth Low Energy. It just measures, there are sensors that measure the pressure in your vehicle, in your tire, and then they relay that through controller area network protocol, CAN protocol, to your cluster. So the cluster will show whether the number as well, whether it is 36 psi or whatever is the unit you have used, and whether it is low pressure. Even when there is a puncture, if some nail comes in, it will detect that and show. That is the functionality of TPMS. VCU is bit more advanced, vehicle control unit. So as again Guruji mentioned, cars are seen as mobile computers or computers on wheels. So there are a lot of software features software and hardware electronics that go into a car. And just like mobile phones or smartphones, it's possible to update the features of your car. And in the US, the Tesla is offering such kind of models where you buy a car with limited set of features, and then if you want, you can buy a sports package where the mechanical devices must of course support that, or in electric vehicles, the motor must be able to support that. You can get additional horsepower or additional torque, or increase the battery range, or if you have already camera but it's not enabled, you can buy the package to use some of the features like surround view monitoring or emergency braking. So this kind of architecture is possible to be realized using vehicle control unit. So software-oriented architecture in software-defined vehicle. These are typical terms if you're from the automotive industry, you would have heard of. If you have more questions on this, there are some resources that I mentioned in the note section of this slide, or you can contact me. I am in the group, so you can contact me so we can have a discussion, or there are job opportunities as well related to this if you're an expert on any of these fields. And telematics is telecommunication combined with informatics, so information and telecommunication, and then get the data from the car, various data like the location of your car, or where have you driven your car, the track record, driving track recording, how you have been driving, very aggressive or smooth, or applying a lot of brakes and accelerating unnecessarily, braking and accelerating. And if there are any faults, so there is so much electronics in the car, so one of the devices could be faulty, so it has to monitor that, and where you're located, and then see various other parameters in the car, like whether you have unlocked properly. So there are cases where the completely keyless cars are there, where you don't have a key, but you can unlock with your mobile phone. So it authenticates with using various mechanisms. And then automatic window control or wiper control, where there is rain, you switch it on or off, engine start and stop. So all this data can be collected and then used in telematics application. This can be used for fleet management. Some of the commercial vehicles, they want to make sure that the driver is not taking the vehicle for his own personal usage, or going to his own village or native city or something, or is driving properly, or if there is an accident, they get the notification. And this can be used for further applications, like by insurance companies. If the data is recorded, and they can show if there is a video camera recording that, they can show that whose fault it was, to detect whose insurance will pay for the damage that has caused. So all these combined come to the telematics area. So this is just another example in the vehicle control systems for automotive. So now, again, another quiz. You see all the three questions, but I'll start with the question 1 of this quiz number 2. Name any 2 commonly used communication protocols in the automotive application segment. So I will switch to the chat window. If you have observed that, it's okay. Otherwise, also we are coming to the end of the presentation, so it's okay if you don't. It's already Saturday 9 o'clock, so it's fine. I guess the participation is a bit less here. Don't see anybody sending the answers. Communication protocols that I mentioned earlier in one of the earlier slides. Yeah, all of you are correct. Yeah. TCP is not that much used in automotive, but yeah, okay. But CAN, BLE, Ethernet, these are all the protocols that are used in automotive. Yeah, that's correct. Vidya Shri, I think one game Arun mentioned 3, so yeah, those are correct. I2C is a microcontroller peripheral, so it's a very low level. You are right, but it is not considered as an application level protocol. It's more of a microcontroller, and to communicate between devices at the microcontroller level, you use this inter-chip connect I2C protocol. Yeah, that's the explanation for that. Okay, so next question is what does DMS stand for in automotive ADAS? I gave a lot of scenarios for this DMS use case. So if you remember what it stands for, please type that in this chat window. To monitor the behavior of the person controlling the vehicle. Yeah, I know who gave the answer. Yeah, that's the right one. Driver monitoring system. So basically it continuously monitors the driver, his behavior, and this has various issues. So there are privacy issues as well here. So that you can store the data in a safe way. But otherwise, the main aim is to make sure there are less accidents. If you're drowsy or inattentive, you get at least an audio warning or a haptic warning where the steering wheel or itself vibrates. And in the worst case, apply the brake. At least you avoid the accident. So driver monitoring system, yeah, DMS stands for that. And the next one is related to the tools, which is very useful. So I know that a lot of students here as well. So which one of the following is a PCB layout and designing tool? Is it A, Control Desk, B, Vector Da Vinci, C, MATLAB, or D, Altium? So please mention the option alphabet or the answer itself. Yeah, most of you got it right. Yeah, D, Altium. Yeah, I think the first one was a bit tricky. Name of the protocols. I think then there was more participation. So I think happy with that. So then next is the last part of the presentation where I have 10 to 12 slides. So it won't take much time, but it is all explaining various applications. So it will be interesting. It's not, I won't be explaining any technology or electronic components, but just talking about applications in other industries like wearables, consumer electronics, healthcare. So that will be the next part. And then in the end, there will be again one more quiz to wrap the session up, and enjoy the rest of the evening. So, okay, so I'll switch back to the presentation mode and go to the next slide. So the next slide is the applications which are also very much used by all of us, consumer electronics applications. So first is a smart pen. So I think some of the advanced phones or tablets come up with the stylus, as we call it, smart pen or stylus, where you can write on the device. So this will record the human handwriting and store a copy in the digital format. And how it does is it uses one infrared LED, IR is infrared LED, to emit light onto the paper or the screen. And then an LED sensor will detect the reflection. And this sensor will allow the movement of the pen's pattern to be detected and recorded. And even there are, with the AI features, if you just write haphazardly, it can also make it, type it in the font you want. Or if you're writing a rough 3-sided diagram, it will recognize it to be a triangle or a rectangle or square. So that is where AI comes into that. This is done by feeding the device with a lot of images and then teaching it just like how we teach humans. And then based on the memory of this knowledge that it has learned, it will recognize the future input. So there are things like neural networks or fuzzy logic that is used to feed AI, to do the AI stuff in this smart pen. And then there is other useful, very interesting application called remote controlled PC water cooler. So what this does is it uses a cooling process to lower the temperature of the computer processors and other critical components, right? So PC water coolers absorb the heat away from the components inside the system rather than blowing the hot air around the case. This is what it does. So it absorbs the heat away from the components and then dissipates it in a different way than just blowing it hot air in the surrounding atmosphere, or which is typical with the air cooling systems. So this is especially needed in high-end computers, gaming systems, and even advanced cooling is used for the servers that maintain the cloud of Amazon, AWS, or Azure. So these kinds of systems use much advanced cooler, but this is for a remote desktop or gaming systems. Other is home theater and entertainment. So you have seen this voice user interface. So there is graphical user interface, GUI, to use the tools, and there is VUI, where you can speak to your fan. So switch on the fan or increase the speed, speak to the smart speaker and say, hey Alexa, or hey Google, play me, whatever, tell me the weather. So this is called the edge AI. So when you speak to a fan, it's not connected to the internet. So there are some keyed in commands that it recognizes even when there is distortion in the voice, or you pronounce increase the speed in a different way than I do. It is trained to recognize this. It will not connect to the internet and check a big database or connect to servers. This is the edge voice user, edge AI that I'm talking about. There is one of my colleagues, Venu, who is more expert in this topic, so you can ask him also questions later or contact him. But this is what is meant by edge VUI. So this controls appliances like fans, lights, window blinds. You can even, other applications in your appliances in your home that can be controlled with this. Then video IP phone, you might have seen there is a conference room and there is a video, and it will rotate depending on the direction the voice is coming from. So it will focus the lens on that person. And then when he stops or somebody else speaks, it will go there. If multiple people speak, it will zoom out and focus on most of the people that are speaking or where the voice is coming from. There are various technical technologies here like voice cancellation, active voice noise cancellation, active noise cancellation, and focusing depending on where the voice is coming from. And then for this, you will have mechanical buttons, small motors that are moving, and then you have to connect it to the internet because it has to show that to the people connected online. So this is the video internet protocol phone, video IP phone. And then continuing in the consumer electronics, there are power adapters and chargers. You have this online UPS. The online UPS, most of us use UPS in our home. The conventional UPS, what it does is it gets the power from the AC line, the mains, and then charges the battery. And only when there is power disruption, this battery will give power to the end device, be it your refrigerator or fan or TV, whatever is the wattage or whatever is the battery capacity, that much power is given. But online UPS, what it does is it continuously converts AC line power and feeds it to the battery and then in turn to the end device. So it is continuously doing this. So what this makes is it gives, you can monitor if there is any power failure, and it is more efficient overall and also more expensive because you're continuously doing the AC to D from mains to the battery, AC to DC conversion, and then from DC to the device again AC. So continuously this is happening. This is why it's called online UPS. So this is a very interesting application where there is high efficiency, there is fault monitoring, and which is why it is also more expensive. Then universal NFC charger. NFC is near field communication. This is a versatile USB charger with which you can do wireless charging of small battery powered devices like the smartwatch I'm wearing or tablet, even the payment cards. When you go to some guy in the shop, will ask Wi-Fi, yes sir. By Wi-Fi, what he means is this NFC. It's not exactly Wi-Fi. This is near field communication technology. This is what is there in the chips, and you can make payments with your watch or phone. So all this is enabled by this NFC charger. And there are various components, electronics and semiconductor devices that go in. Again, for all this, there are links shared. What I've used is from my company's website because I know how it is designed and where I can search for that. And I'm not saying ours is the only company that offers these kinds of solutions, but you will get a good idea of what are the solutions, even the block diagram, what microcontroller is used, what Bluetooth module is used, or what power management IC is used. So make sure that only 3.3 volt is given, for example, because these are all small devices, right? So you can go and have a look into that. And if you have any questions, you can. In this BGSVSIT group, there is me and Venugopal, who are a bit experienced in this. For more technical related questions, you can ask him, or more business oriented questions, you can ask me. Just mentioning some resources for further questions. And then wearables, as I mentioned, smartwatch, there is smart ring as well. So there is one company called Ultra Human or Moose in India who makes this kind of smart, mine is not a smart ring, but you wear that over there. And what this can be used is to, it can monitor your health, it can monitor your heart rate, temperature, and use those parameters to see whether your stress level is high or low, or breathing pattern, all this can be done, and also used as a fashion accessories, right? So this will be coming equipped with the technologies like NFC payment. You can pay with your ring or smartwatch. Authentication service, you can use a smartwatch to open your door or open the car. And then these are the digital experience that make your life easier. And then there are personal safety trackers with the GPS, NFC, air quality sensor, which you can use on your kids. To wear, the kids can wear that, or if you nowadays most of us are also attached to the pets as much as the kids. So pets may be wearing that, and you can know where they're exactly located, if they've gone out of school, or depending on the use case or the parameters that you monitor, you can come up with a lot of use cases. So that's what is possible with this personal safety tracker. Then I'll move on to the industrial applications, which are not as relatable to all of us, but I'm sure many of us, because we are from the technology background. Smart toilet is one of, I think, many call it a Japanese toilet. Maybe they used to use that as the first. So this is where there is features like the seat will be heated or it can be dried. And there are other features like I'm show here. This is the touch panel button where you can increase the tiltness of the seating position for taller or shorter people. You can connect your phone. These are very, as Guruji said, these are all things that make our lives easier, but they also have environmental impact. So, and they also cost a lot of money. So, but it's possible. That's what we are trying to explain, that if you use the technology responsibly, it will make our life easier. And that's what our aim is. So this is smart toilet application. HMI is human machine interface for all kinds of applications. So my watch has an HMI where I can touch or rotate the bezel and control various features. My phone, your car, there's a touch screen, and your cameras. If you're entering your fridge as well, water washing machine, in the industry as well. In industrial, there are robots or machines where you can touch and control. So nowadays, touch screen is what everybody has. Touch screen is here, touch screen is here. Some people even know whether it is capacitive touch screen or resistive touch screen, where you have to hit it a bit harder. So these are the various applications that HMI is used. And again, we go a step further. We want HMI to be like our smartphone. So there is Android-based HMI, or there is a HMI that looks like an Apple phone or Apple device. Or in industrial use case, they don't care much. It's functionality that takes precedence over there. So there they use some other operating systems. So Android or Apple devices, they're all operating systems, right? So in industrial use cases, they use different operating systems. So again, here you can have NFC technology to authenticate. As soon as you take your watch close to the HMI device, it will authenticate you, let you in, or take other actions. Switch on the machine in the factory or switch it off. All these things can be done with HMI. This is the basic, the high level interaction between humans and machines. Then continuing in the industrial applications itself, metering. This is the one that I mentioned, automated meter reader retrofit module, where the convention, this is being pushed by the governments, India, Karnataka government, various states government, and the central government, where nowadays, if you've seen the BESCOM guy, or if you're living in another city, MESCOM or whatever, HESCOM guy will come and he won't exactly read the numbers on the meter. He might make an error. So he will have a device and there are some authentication methods. He will go near your meter and it will read the exact value for you. So you don't need, this is what is meant by metering. This is for the electricity, similarly for the water or gas flow industry. So this is what the metering solution. So there are various microcontrollers, communication protocols to transfer the data or the exact reading from your meter to the device, and then calculate how much you have used and apply the per unit price and then give you the bill. So this is what automated meter reading does. So there are completely digital meters or these retrofit modules where the BESCOMs or the electricity supply companies are slowly equipping themselves with the digital meters, where there is a big push from the government and subsidy, and companies like ours are working with the government and the industry players to provide these kind of solutions to the electricity supplying companies or industrial players. And then there is power system for smart power meter with connectivity. So this is basically where you have a smart power meter, and then these are all low energy applications again. So you use something called electrical double layer capacitor or super capacitor, which will give you power for a short duration. You don't have to have a battery, coin cell battery or something. You can use the super capacitor, and then when there is power disruption, the charge stored in the supercapacitor is released for a few minutes, and then till the power is back, or where the UPS is back up and running. And then you can communicate this, the status of the system or other parameters, monitor that, and you communicate that through 4G or 5G, whatever connectivity module you have, and then monitor it in the dashboard of your control room, wherever it is. So that's the application here. And then moving on to within the industry itself, I'm moving on to medical and healthcare. I'm trying to mention only few use cases that we can relate to. I know we might not have used all of this, but at least we can imagine that based on our experience and knowledge, or even if you have used it, you can relate to that. So this is the continuous glucose monitoring with the closed loop operation for insulin pump. So what it does is it will basically inject the exact amount of insulin, and then so that you don't have to continuously prick your finger or wherever you're doing the insulin injection. So that is what it does. And it will also monitor the blood sugar levels. So if you forget it, it will remember on its own and give the appropriate dose. Or if there is some up and down in your levels, it will take care that the optimum amount is infused into your system, into your body. And then there is in the hospitals, high-end hospitals, we have these kinds of things where secure drug delivery system with authentication and rich connectivity. So what it does is it will give the right amount of drug or the medication to the patient. It will make sure the drug is valid, that it is not post its expiry date, and given at the right time in the right amount, and then communicate it to the nurse or the doctor. So this is more of automation, so less of human intervention. So there are pros and cons. Of course, I'm not going to discuss on that, but at least it will make sure some of the errors are taken care, or some of the human errors so that are minimized. So this is the application. As I said, using NFC, it makes sure the right drug is given, there is no expired drug that is given, or counterfeit drug, and in the right amount. So this is the application for medical and healthcare. And on the other side, extreme end of this, where I said pulse oximeters or glucose monitors in rural health areas, that is also equally important, because maybe 5% of, or even less number of percentage of people will be able to take advantage of these kinds of features, but the rural healthcare is much more accessible, or will be beneficial to the people in the countryside, in the villages. There also you can use electronics and semiconductors. And the next one is another infrastructure use case. So I was talking about cloud, or the huge data centers where all the cloud data is stored, or you have this 5G, 6G, and Wi-Fi routers where they are employed in these data centers. That's another use case where very high speed is achieved with the Wi-Fi 6. So I think currently in our house we have Wi-Fi 5, maybe 5G, but next generation, or maybe it's already there, 6. So where you can connect multiple devices like your internet protocol TV, cable-less wire routers, or set-top boxes, your Tata Play, or anything else that you have. And then combine this with front-end devices. That means you collect the data from these devices and then switch it off if nobody is using. If the channel is showing the same thing, it will switch off. Or communicate between each device, so you can connect your smartphone to the TV or through your phone. So all these need high-speed data, right? So you can't enjoy if the song is playing slowly, or if you're watching a movie, it is lagging and buffering, and you don't enjoy that. So this is the other application where multiple devices, multiple communication protocols, authentication and secure mechanism, all these are taken care. And I think I'm coming to the end of the session. Two more slides and the last quiz. Some applications where artificial intelligence is used. Almost all the other applications that I mentioned, artificial intelligence is used, where you measure the quantity of the medication done without human intervention, right? So that's artificial intelligence. So other application is where at the construction site, you make sure the worker is wearing the right safety mechanism, or the helmet and other shoes, and make sure otherwise he will not get access to that. So this is one application. And this last application is quite interesting, which is called sound recognition, or See with Sound, SWS. This technology was at least patented by a company which now belongs to Renesas, that is my company. And what this does is, so most of the autonomous driving will use camera or radar. So camera is directly capture the video and analyze the data. Radar is radio detection and ranging. So radio frequency data is sent, and then you don't, even if there is low light, radar will work. And then you measure the distance more accurately than camera. And then you apply the brake, or you monitor the driver, even in the night condition, whether he's sleepy, you can give some notification. But what this see-with sound technology does is, when you enter a junction of road to a highway from a smaller road, and there is an ambulance or some vehicle coming at a high speed at some distance, your camera cannot see that, because for camera light is needed and is only line of sight. And radar also has a limitation in the angle of detection. So it might not be able to detect a vehicle that is 500 meters away, or ambulance that is speeding up, or another vehicle that is speeding up. So there are a range of antennas that are configured in the right way. And these antennas pick up the sound, and then it will feed to the car, or the microcomputer, or the microprocessing unit in the car. And this data is combined with camera, radar, or LiDAR, which is light detection ranging, and then it will improve the safety. So that's the main application of the see-with sound. So this was done by a company called Reality AI, which is acquired by Renesas. Now it's a Renesas company, but I'm just explaining these are all possible with AI. So another thing to note is, all this data has to be fed to the car, where there is a high-end microprocessor with 8 cores or even more number of cores is running. It receives all this data, then does the calculation on distance measurement or something, and then has to give the input to the actuators, whether to apply the brake, or steering wheel, or apply the torque to the steering wheel, or haptics to give input to the driver. All this should happen in milliseconds. So that's where high-end microprocessor or electronics and semiconductors play a big role. So that's what I was trying to say. Now some of the terms for academics and industry collaboration. So most of I mentioned this because our BGS has a lot of colleges and institutions where some of these courses are taught. So if people are interested, if you're already studying in this, then you can apply. You can have a career in semiconductor and electronics, or you can still do another course. Or if there are children in your house who are interested, you can educate them. So if you are studying in fields like electronics and communication, electrical engineering, instrumentation, so wherever solid state physics and digital electronics is applied, that is where you can have a career in semiconductor and electronics. And coming to the industry collaboration, so there are various industry bodies or collaboration between companies and industry. So there is a body called India Electronics and Semiconductor Association, IESA. So this is headquartered in Bangalore itself. So most of the semiconductor and electronics companies in India, they are members of this, and they conduct many events. In the beginning of this year, in January, we did an event. We means they did, and Renesas was the gold sponsor for, my company was gold sponsor for this event. And it was also Karnataka Digital Economy Mission was part of that. So various principal secretaries and ministers, even Rajesh Chandrasekhar, although virtually, he did participate in this. So there are these kinds of industry collaborations. And Renesas, again, I can talk about what my company has done. So there are other companies also that have collaboration with various other institutions. So we recently signed an agreement with IIT Hyderabad for research and collaboration in the field of VLSI and embedded semiconductor systems. And then IIT Bombay has a Center for Semiconductor Technologies. It is called CEMIX. And the professor from IIT Bombay was at the ISA event in January this year. So you can again search yourself on the internet or talk to one of us in the group like me or Venu or Praveen sir is also there. He's from Continental Automotive Supplier. So he will also be aware of many industry events. So you can talk to us, and if you're interested, you can participate there. You can, apply for jobs or just to know the latest technology, have participate in discussions and learn from the industry experts. So I think this, one more slide. I think these are the kind of skills that you can equip yourself with to have a good prospect of getting a job in semiconductor and electronics companies. So you can be good in embedded C programming, microcontroller, peripheral communication. Somebody mentioned I2C, interchip connect, UART, universal asynchronous transmit, or SPI CAN. If you have expertise on this, you can get a job in electronics and semiconductor companies. And next level is if you have worked with advanced microprocessor processors, or SoCs as we call it. SoC means system on chip. So there is microprocessor, there is a main processing unit, and there are various peripherals, sometimes including memory and some interfaces like camera or others. So that is what SoC is. And these typically run on operating systems like Android or Linux or real-time OS. Microcontrollers like these, they directly communicate with the hardware, these protocols. So it's like you just write the firmware for these microcontrollers to interact with the hardware. But if you have experience with MPUs or SoCs and expertise in Linux, BSP means board support package, Linux or Android or real-time OS, you have a very good chance of getting job in. Especially currently, this is very much in demand. And you can, if you have knowledge about various tools like eSquare Studio, MCU Express, so these are all vendor-specific tools, right? So you don't have to know all of them. As I mentioned earlier, depending on your expertise and your academic background, you can choose to learn those tools. MATLAB, Python, System Verilog, all those things, and Altium, Cadence Virtuoso I mentioned for PCB design. And if you're working at a lower microcontroller design itself, then you can work in RTL or FPGA, do an FPGA programming, which is application specific, and then deploy that for a specific application. So if you are experts on this, you have a very high chance of getting a good job with good salary in the industry. Different job titles or designations are like this. This is not an exhaustive list by no means, by any means. So it's just some of the list, some of the names that I picked up: embedded system specialist, PCB layout, schematics design experience, hardware design in this RTL or FPGA, firmware and middleware development like BSP or microcontroller programming. Analog and mixed signal is where you work with power electronics side. Like as I mentioned, right, GaN, wide band gap. So there are power electronics devices that are used that operate with and handle powers in the range of thousands of watts. So there, if you have experience on that, or analog. So I spoke about digital, but analog, like all this electronics needs clocking or timing devices. That is the basic oscillator or a crystal. So if you have experience on analog side of things, like design of a regulator, design of a power management IC. So you also have a lot of demand and good job opportunities in this. And if you're done these things for a long time, or if you're like me, not a specialist in anything, but you can talk about this and do technical marketing of this or sales of this. But this you will come with experience. It's difficult to join technical marketing in the beginning, unless you are an expert on technical topics. In those cases, you would mostly want to do the technical job. You wouldn't want to do this. So even I started technical job in automotive industry doing software development for ECU, then verification, validation, all those things. And in the last 9 years at Renesas, I have been doing marketing and now sales job. So this is how these are the various skills that you can equip yourself with, and based on that, you can get different kinds of jobs. So this is the final quiz. Sorry, I'm a bit late. These are the final 3 questions. And after that, there is a Q&A session. There is no compulsion for you to stay for that. It's already quite late on a Saturday evening. So anyway, let's start with the last quiz. So name any 2 commonly used communication protocols in the industrial application segment. Previously, it was automotive. So I mentioned way more protocols for the industrial use cases. If you remember that, I know it's a bit more technical. So please mention those names in the chat window. I mentioned about EV charging, if you remember the name of that protocol, and other things. Yeah, I know it's getting late. Many people are leaving the meeting. Wait, it will be done in a few minutes. Yeah, sorry for taking. Yes, Modbus is correct. Yeah, again, those are UART, I2C are low-level microcontroller. Yeah, I can take that, but I was looking more into the other communication protocols that I mentioned in one of the slides. Industrial use case. So when 2 robots want to communicate with each other, or IoT, where 2 IoT-enabled devices want to communicate with each other, or home automation systems. Yeah, Profibus. Yeah, I think Aruna might have worked with this. That's why, yeah, they have some of the, yeah, it's right. So Modbus, Shademo, as I said, or I will show the slide itself, or I will share it later. I think it's already quite late. Wi-Fi, BLE, yeah, this was the most easy one. I thought most people will mention Wi-Fi and BLE. That is widely used. EtherCAT, DALI, DALI, I mentioned, Profinet. Yeah, this is a more technical, but I wanted to at least test some of the people who have this background. So next I'll move on to some less technical but still widely used. So what is the technology used for contactless or wireless payment methods? So is it A, Wi-Fi, wireless fidelity? Is it B, NFC, near field communication? Is it C, Bluetooth low energy, BLE, or CAN, controller area network? So either mention the alphabet of the option or type in the name itself. Yeah, many have mentioned B, NFC. Yeah, that's right. I mentioned, using the phone, or as the shop guy asked, Wi-Fi, which is actually not Wi-Fi, but it's NFC. That's right. That's the technology that is used for digital contactless payments. This is the last question and also the last point from the last I will speak in this presentation, unless you have any questions. So what is the level of autonomous driving needed for complete hands-free driving? Is it level 2 plus, level 4 minus, level 5, or level 3? Yeah, 3 people have answered. Yeah, it's level 5. Yeah, I think that is option C. No, complete autonomous driving where completely hands-free in all situations. Maybe I didn't mention, not only in city, but everywhere. According to the industrial term, it must be, the industry term, it must be level 5, where there can even be no steering wheel at all. You just sit in the car, talk to the car, tell where you want to go, ask what music you want to listen to or what video you want to watch, then it will do that. So that's level 5. So that's it. It's 20 minutes late, so sorry for that. I again thank Swamiji and BGSVSIT for giving me this opportunity to present. So thank you, ladies and gentlemen, for giving this opportunity and having the patience and time to participate on a Saturday evening. So I'm grateful for that. So if you have any questions, please, you can discuss now, or you can contact me and my colleague Venugopal, who is also in this group. He is from a semiconductor background. For automotive questions, there is Praveen Rudrapatna, who is an expert in automotive related stuff. You can contact one of us. Thank you, everybody.
Thank you very much.
Madhunandan. Yeah, or Murli.
Yeah, thank you, Madhunandan. Definitely, even though it is a little late, but definitely it's a lot of information for everyone who has been participated and listened very patiently. Almost 2 hours to 20 minutes. Thanks everyone. Thanks for all your time. And just for vote of thanks, I will just request Polia, okay, Krishnappa Polia to do that.
Thanks, Murali.
Yeah.
Okay. Jai Sri Gurudev. Namaste, everyone. Good evening, everyone. With the blessings of Sri Dr. Parama Puja Balagangadharanath Mahaswamiji and Sri Dr. Parama Puja Nirmalananda Mahaswamiji, on behalf of BGSVSIT Professional Trust, I would like to take this opportunity to extend my heartfelt gratitude to all of you for joining on this wonderful event. Today, on this most wonderful evening, on behalf of all of us, I am very much delighted to thank Sri Dr. Parama Puja Nirmalananda Mahaswamiji for attending this webinar out of his busy schedule and inspiring and enlightening us with the importance of semiconductor and this event, and also blessing all of us for our happy life and bright future. Now, I would like to extend a vote of thanks. Firstly, we are grateful to our esteemed speaker, Mr. Madhunandan, for volunteering and delivering such an insightful and career-oriented presentation on semiconductors, market trends, and career paths. His expertise and engaging in delivery have provided us with valuable knowledge and perspectives. Thank you, Mr. Madhunandan, for pouring this knowledge on semiconductor technologies, its building blocks, the industry and applications, and also mentioning on various career paths, skills to acquire, and job opportunities. Thank you, Madhunandan, sir. Secondly, to our participants, thank you all your active participation in this evening and answering all those quizzes. Your engagement made the webinar more dynamic and meaningful. Last but not the least, we also want to express our appreciation to our organizing team, that is the BGSVSIT core team, and volunteers who involved directly or indirectly to ensure smooth execution of this webinar. We hope you found this session as enriching as we did. We look forward to your continued involvement in our future events. Once again, thank you all of you for your time and contributions. Have a great evening and weekend. Thank you once again.
Thank you. Just one question. So, can we? Should I share this presentation with you and or somebody, and they will share it further, or is it not needed?
Yeah. We can share it, Madhunandan. So definitely,
okay.
Yeah. So,
okay. So I will remove some of the slides about my introduction and maybe even quiz, because that's not really needed, and then. I will share the presentation in the PPT format itself, because in the notes section there are a lot of links that will be useful for you to get more details and even job opportunities. I've mentioned some from our company's career site, so you can have a look over there. That's why I won't convert it to a PDF. I will share in the PPT format itself.
Yes, exactly.
Thank you. No, so yeah. Right. Yeah. Thank you. Thanks for saying that. Yeah, I will maybe include my at least email contact so that you can contact me. But other unnecessary stuff about me, I'll remove. Yeah.
Even those who are having some questions, they can able to send it to connect@bgsvsit.org. So I have already mentioned that email ID. Okay, in this chat box. Okay, if anything else is there, if you have any questions, please send it. So definitely we'll get back to you. And then at least thanks for all your time and your contributions and listening at least 1 hour, 20 minutes. Okay, so now happy evening. Have a nice